Alright, welcome to the stream, everyone. Things are going alright. It's Saturday here, and Tuco is on the rack, right on schedule. Oh, it looks like we're missing the topic bar at the top. Tuco's lounging around in the rack. You momentarily fixed that text that's supposed to be at the top of the screen. Gotta have our glitch for this stream. We just rebooted that machine and I guess it lost its login cookie. Hey, Duke. Just gonna let you all enjoy a little bit of cat while I fuss with a little bit of technical glitchery over here. I ended up being surprised by Windows Update right before the stream, and I thought I had everything set to start up correctly on boot, but there's this one little kludge that I have for getting the little browser overlay that sits at the top of the screen to actually log into Gitter so that it can connect to a private channel where I have the topic. It's a little bit convoluted, and honestly it hasn't been super useful, so I might end up just dropping that feature, but at least right now fixing it just involves logging into Gitter on this other computer that I have sharing cookies via a proxy. So is this gonna work? Looks like this other computer is still connected. Maybe I just have to restart the actual browser up here. Oh yeah, look at that. Whoops. Come back. That's interesting. It worked for a bit. Oh, okay. So the blankness is not a login problem. I think the blankness is just a rendering issue. I don't know why it was blank for a bit, but I guess it's back now. So, I thought I'd start out the stream with both a little bit of cat and also maybe just a little bit of context for anyone who's tuning in who hasn't been following this project stream by stream like I have. So this overall thing is sort of a robot project where, well, the overall thing is that, hi, I'm here and I'm doing projects on YouTube, and my kind of overall goal is to do things that are kind of educational, specifically around reverse engineering and low-level electronics, or low-level kind of systems programming and embedded, and you know, just generally making things, but also a lot of the layers of technology that accompany that, and going into detail on those, and engineering forward and backwards. So that's kind of generally what my channel is about. But recently I've been kind of doing this little project binge where I've been trying to just crank out this robot system for interacting with my cat over the internet. And so, you know, this is something where, you know, I plan to focus on other things once this is more working. But right now I thought I'd just try to do a little bit of a sprint on this and just try to get to a point where I can actually have this robot that hovers around my shop and carries around my cat cam and allows all of you fine people to interact with my cat both during the streams and just anywhere else, any other time during the day when the robot's operational. So that's generally what I'm doing here. I'm building a robot, I'm documenting the process, I'm doing these streams when I have some interesting work to do to show directly, but I'm also collecting footage that I'll edit down into videos. I already did a couple on the gimbal and kind of on an overview of this project. So if you go to my channel or just search for scanlime on YouTube, you can find the last couple of videos. And in fact, the easiest way to see them in order is probably just to go to the website that I have for the video blog, well, it wasn't always a video blog, but lately it's been a video blog. If you go to scanlime.org, like Scanline, but fruitier. If you go there, that's kind of my, my blog/video blog with all of these projects. And it has some of the more finished aspects of this, like the gimbal that we've modified to hold the camera that's actually going to be tracking Tuco. But today we have something a little bit more straightforward. It's just involved a lot of work on my end. So this week I've been busy with a couple of things, doing CAD and 3D printing for mechanical parts on the robot, and learning a new programming language, which I've been wanting to learn for a while, and I'm getting some senses of deja vu because I've actually gone into it a little bit in the past when it was much, much younger, and then I don't even remember why I stopped at the time, but a lot's changed, and it's looking really nice. So I've been finally taking the time to learn Rust lately. And so as I was saying, I'm kind of a systems programming nerd. I really like the software that sits right on top of the hardware. I like operating systems and device drivers and that kind of stuff, and I spent a lot of time working on virtual machines for a day job, and then embedded systems in a lot of different contexts as a hobby, and then sometimes as a day job. So anyway, it's been a real pleasure to finally have a project I can use as an excuse to properly learn Rust. I decided to write the firmware for this robot constellation. So this project involves several different kind of independent robots that all communicate to a central controller. And that's how I'm implementing this system where there's a flying part, and then there are winches in the corner of the room that pull the strings that move the flying part around. So the way I ended up implementing that was to use several instances of this inexpensive microcontroller board. So if we go to the camera over here, this is the board that I've been using for this project. It's a eval kit from TI. It's the connected launchpad, or the Tiva C eval kit. It's got a really weird model number, but you can buy these for 20 bucks, and they have Ethernet and loads of peripherals built in. And I think I might eventually want the firmware for this to be written in Rust, but for the moment it was way easier to base it on the pile of existing C code that's already out there, a lot of which was provided by TI, and just kind of picking and choosing the parts I want. The firmware is pretty simple. It's basically just accepting UDP packets that command it to do different things. So here's a frame of data for the LEDs, or here's a command for the motor PID loop. And then periodically it sprays out UDP packets with telemetry data, so just the latest sensor readings that it has. And it does this currently 250 times a second. And this will have its own little dedicated network with all the microcontrollers connecting to a separate network interface on the PC that does the control. Let's see. So I decided not to use Rust for that. I did want to use Rust for the kind of control software, though, because that's not something where I'm relying on this sort of interface between the microcontroller environment and the application logic, which is most of what the firmware is concerned with. The firmware is very simple. It just sets up the hardware, shuttles values back and forth, does a little bit of control loop. But most of the work I want to be done on the PC side, so I wanted to write that in a language that's a little bit more convenient to write more complex code in. So my first thought was Python, but I thought it would probably be pretty tricky to keep Python high performance enough, especially for the code that I expect to run reliably, maybe 1,000 times a second or so, perhaps more depending on what I end up doing with the control loop. So Rust seemed like a pretty great choice. So I'll be going into that a little bit later if I have time. I'm still pretty early in the learning Rust. I've gone through the language itself. I've read the Rust book. I've been reading a lot of code, but I'm still trying to figure out how to structure everything and what levels of abstraction to choose for everything, and which existing crates to build on, so which libraries to use. And I think I've got a lot of it started out, so I've been starting to build some of it, and I was hoping to have a little example that was at least kind of a slice through the stack that I wanted to build that showed getting kind of LED updates into the hardware, so we'd be able to spray some pixels at the hardware. So I have some LEDs that are, some of them are decorative, some of them are to help with computer vision and navigation, but I figured it would be nice, since we're going to be assembling the LED rings. So these are LED diffusers. These are APA 102 LED strips, and a lot of these plastic parts go with that. So I thought it would be nice to have some Rust code that could spray pixels at that. So I was working on making something nice and idiomatic. That still needs a lot more work, so I could show you what I've got so far there, but I've also got some Python code that works that I showed on an earlier stream, so we could just run that. It just requires a decent amount of CPU power since it's written in a pretty inefficient manner. I also have a really direct translation that I made from that the algorithm in that Python code to just like really basic Rust that I made when I was like partway through reading the Rust book. And I don't know if that works, but we could try that and hack on it and see if we could get it working. So that'll be a little bit later. But I thought we'd start out just playing with this little Lego kit of mechanical parts that I have here. So yeah, I've got a lot of things that came fresh off the 3D printer. So these are LED diffusers printed in NinjaFlex. The flexibility here is kind of nice, but the reason I went with this particular material is it actually makes a pretty good light diffuser. You can find some good examples. A lot of projects use this, like for props. I think Adafruit's done some cool projects on like learn.adafruit with using this for props and light diffusion. One thing that I did here that's a little bit special, I don't know if you'll be able to see this on camera, but you can kind of see this infill pattern is circular. The default infill kind of plots a grid into the object, and that would have caused some really weird light diffusion patterns as you move along the grid. And so using a concentric pattern, it isn't as strong. It squishes pretty easily in that axis, but it's actually just right for a light diffuser. So I have 3 of these, all the same. Oops. I was about to switch to manual focus, but maybe not. Then, also over on the light diffuser topic, I have 6 of these, which hold the LED strips and the actual diffuser. Oh, maybe we do need manual focus. We are no longer servo AF. Yeah. So these have a channel for the LED strip. If I remember right, these are 36 LEDs in a circle. And so my thought behind this is that you could use this in a couple different ways. You could use it to show a direction, so like it could have like an eye that's pointing in the same direction as the camera that can kind of virtually move around this ring. I thought that might be interesting. And since it was easy to have multiple rings with this design, I thought it'd have 3 layers. And with that, I figured maybe you could use those for effects where things move up and down between the rings, or maybe they have different functions. Maybe they just function as kind of resistor color code kind of colorations. Because I thought it would be really useful for people in the space, like me, or visitors here, or people who come to classes here. I thought it would be nice to have some indication of what state the robot is in, like, you know, how is it being controlled? Like, is it like following a target with computer vision? Is somebody just driving it around with the robot or with the joystick? Is it doing something else? And you might be able to represent different algorithmic states on the LEDs, so kind of whatever the computer vision / control loop algorithm is thinking, basically, could show up on these LEDs. And so that's kind of why they're a little bit ambiguous and a little bit generic. It's just kind of 3 separate rings that just kind of form a continuous color that I can address. So anyway, I have these assemblies that each take 36 LEDs in this channel, and then these are all symmetric, so they actually stack. They're 180-degree symmetry. So I can put that here, and then if I wiggle the LED strip just right, it'll actually just fit in that groove. So this will hold the LEDs, aim them outward. That little gap is not quite what I want, but I think there's a little bit of wiggle room in there. This whole assembly, if you'll notice, there are not any screw holes for all of this together. My plan for the LED assembly is that assembling it was probably going to involve a lot of glue, probably black hot glue, so that I can use it as light blocking also. Since, you know, like the LED strips, I'm going to have to glue those in anyway. And so I imagine what I'll probably do is just get the wiring set in each of these rings the way I want it, and then glue them in. But then you'll notice they have this kind of weird pattern in the middle. Each of these rings actually can then stack onto this central core, so there's an element of modularity there. So I can get each of these rings built, then this slides onto here. And so this is still some support material that we'll want to remove, but this ends up acting as a bracket that mounts it onto the gimbal mount plate and covers up the basically everything above that. And so then the LED strips would go in. Well, we'll actually do this in a bit, but the LED strips would go in there, and then diffuser. And then, you know, see, you probably get the idea. Or maybe this is totally weird, I don't know. But something like that. It almost kind of looks like those pieces that I thought looked like kind of fake lights in Lego kits, but these will actually be lights. Here's one without the diffuser, but with the LED strip. And then there's room for the wiring to come out. Let's see, if we take one of these off, oops. So each of these rings has this gap. So the idea is I'll prepare the LED strip with wires soldered kind of at an angle to the strip to come out through this channel and insulate that really well. The wires will kind of follow this channel. This will be an area where I can glue them in for a little bit of strain relief. And then this leads right into, if you see when that's actually stacked up, if the wire comes out that channel, then all the wires can then come up through that channel and then go upwards to the DC converters and the microcontroller. So that's the bottom LED ring. That one is for human interaction and for decoration. It's not especially practical, but I thought it would be fun. Oh yeah, James suggests showing the sensor data on those rings sounds awesome. Yeah, for collision avoidance, that would be great, having like, you know, like some pattern where it's like red, like, oh, get away from me. Can indicate what it's doing. Yeah, that could be great. While we're on the topic of LEDs, you'll also notice maybe these look like places where LEDs could go. So this is the very top of the robot. These will not be especially visible from most angles because the robot is mostly going to be hovering like above head level. But you'll be able to see these if you're looking down from the sky, well, from the ceiling or from the loft here. So mostly these will be useful for showing up on camera. So I'll have a camera up there. I think it might be partly for kind of an actual visible mini-map where I can show that as like a little picture-in-picture on the stream, but also partly for computer vision, so I can maybe automate some kind of pattern on here. I don't exactly know what the boundary is going to be between how much of this is for automated detection and how much of it is supposed to be visible, so I tried to make it useful for both. So the lights have no diffusion, so you can hopefully recognize individual points. There are a lot of options here so that if there's occlusion due to, you know, strings crossing in front of this robot, then maybe I can adjust that. I tried to keep the viewing angle relatively wide by like rounding off those corners a little. And this is also printed out of really strange material. So I was starting to run low on this plain old black plastic PLA that I usually use. Well, This is the stuff that I've been using for a lot of the parts on the robot that I wanted to have good contrast, you know, around other things that should be more visible, so I want them to blend in. So this black PLA seemed to be pretty good for the rings around the lights, for example. And just to kind of match that, I wanted to print, well, and the sensor ring, this is not the actual sensor ring, this is like the earlier version, but I was using it as an example here. This is black PLA. And this is mostly to blend in with all the sensors. But I was running low on that, so I printed this in the Protopasta carbon fiber PLA, which I kind of had for a while but haven't really used for anything. And it's a little stiffer than regular PLA maybe. It's kind of hard to tell. I don't have like an identical regular PLA part to compare this against. The main difference is the finish on it is pretty weird. So it's definitely, it's more matte, but it's also kind of, I mean, I would describe it as anisotropic, but I don't know if that word makes sense to everyone. It looks like, depending on the direction that the printer was traveling, the reflectivity is very different. So it gives it kind of a weird finish. And this is a part that not a lot of people are going to be seeing, but you know, it'll be on camera, in a little camera at least, so yeah, it might be interesting. This is fresh off the printer, so it still has a little bit of boogerage on it. Oh, cool. James is pondering more modular Lego-style 3D printed parts. I think that's totally a thing. I think there's some pretty cool stuff on Thingiverse. Like, it's really challenging to make a good kit of modular stuff. And then I think for that to be compelling, like 3D printing is so slow and there's so much, like it costs so little to customize each individual part that you print. So for it to be, like to make a kit of stuff, I think it usually makes sense to have more of like a molding kind of production mechanism. Man, I've been really paranoid about smells lately. There's like, something's weird. Is that something on fire? Is that something hot? No, I think it's because there's an industrial kitchen nearby and they're making barbecue. I mean, some of it has been like really weird acrid stuff because they're actually doing like road work outside. So a few boogers, but maybe this is time to bring out this tool. This is my favorite little 3D print cleanup tool. It is just a little spring steel chunk with a little bit of grinding on it and a silicone handle. So then on the bottom side, this is where I have some more question marks. So you can see some support material to remove. And this is where the LED strips are supposed to fit in, and then I have some room for wiring, because if I show how these stack together, there really isn't much room for wiring there unless I add it specifically. So I'm skipping ahead a little bit. This is the next piece that goes under it. How does this work? Right, I haven't really cleaned up the holes in that bottom piece, so it's kind of hard to see where everything goes. So we have something like that, except actually lined up and actually in focus, all of those things. So yeah, this is the very top of the robot. So in the middle, that's where the cable leash goes in. I have that over here. Yeah! This stuff is so funny. I'm a little worried about the noise with this stuff. Some folks were suggesting the nice nylon weave wrap, which could be nice. I'm a little concerned with how you actually get that on a cable this long. I think that's going to be a huge pain. So my current inclination is to just not worry about the noise on this yet and maybe fix it later, because I've already done all the cable. Anyway, so that fits in there. There's a strain relief that'll go under here to actually clamp it. And this is how the actual load-bearing cable mount actually works. So each of the nylon cords from the winches come in through here. These arms just help to guide the cable and keep this from moving around relative to the top plate until it gets to the center. And then it kind of loops around through the actual main load-bearing piece of plastic, and then you tie a knot at the top. This was very hard to fish through. I have a tool that might help with that we'll try out. So then each of these LED assemblies will be lined up with the cords, so they'll kind of point in the same direction, which isn't necessary, but I thought would be aesthetically nice. And it also means that the LED strip is sandwiched right between this piece and the top plate there. I'm a little worried about this flex. I might end up having to glue this down. I mean, it's not terrible if this flexes up, but I won't like it. But maybe it'll be fine once this is screwed together. So yeah, the idea is there are screws holding these two pieces together. The carbon fiber rods are clamped down through these screws and then go down to support the rest of the robot. So let's see if the channels here actually work out. One thing that makes using cable wraps of various sorts tricky there is that I've got those large BNC connectors on the end. I could cut off the connectors and re-terminate them, I guess. It's just nice, like this stuff you don't have to re-terminate the cables, which is kind of handy. So yeah, this seems pretty sturdy. This is, man, I had a really hard time printing this piece, and you might notice this print actually did not come out perfect. There's a little bit of warping on at least one of the arms, but it wasn't really enough to cause too many problems. And the build plate got bumped for a short duration of the print, so I have some layer offsets, but I think it'll still be usable. It seems like it'll be strong enough at least. So we have some channels here to allow wires to go through. If I put this through the kind of mock-up sensor saucer here. So there will be some wiring on top here for the LEDs and sensors, and then those wires will go back through these channels kind of concentrically around the umbilical cable. And then the carbon fiber rods pass through here. And what else do we have? So that's kind of what we have up here. This is the sensor saucer with the sensors installed, the carbon rods kind of sticking through. And then there's just a bunch of stuff that clips onto these rods. So first of all, this is another brand new piece that I've completely not tested yet. This is a strain relief. So the idea behind this, these pieces are, again, 180-degree symmetry. So they go together like that. I should have added some more alignment guides, but whatever. So they go together this way with screws. These little ridges hold a flexible piece here. So the outside here is PLA, the inside is NinjaFlex. And there's some little ridges on there to maybe help make it a little more grippy. So my hope here was that this would be the right diameter to provide a good amount of tension on the wires without being impossible to close. Let's see if that worked out. So I don't know how hard this is going to be to get around all the pieces. So I should just be able to put that through. Yeah, I don't want to bother terminating the RG45 quite yet. Or the XT60. I do actually want a decent amount of this cable exposed internally to the robot. So this length is probably actually going to want to be different, but I'm just going to see if this fits right now. So this is the piece. I don't know if this is going to work. I think I want to try to tighten this more. I also don't have to close it around that. I mean, this blue thing is honestly probably enough to hold the crinkle stuff in place. So, yeah, let's see how well this closes around just the wiring. It might be too loose with just the wiring, though. Oh. I don't know, maybe that's great. Well, let's see what it's like with the crinkle in there. I can always cut away the crinkle like it's insulation. Oh, Alistair is asking in chat if this is the replacement for the flexible strain relief I was struggling with last time. Yeah. Yeah, I decided to not make the whole design flexible. Yeah, maybe not. Maybe that's not happening. So let's try not with that, but what about just on some tape, like right here? Because that might be great. Ken is asking about concern for lack of continuous flux rating. No, I mean, that sounds expensive. That sounds like I can just replace these cables for a lot less than it would cost. Oh, interesting. James has an interesting two-part flexible design. Oh, I think this might work. This is feeling snug. Oops. You'll notice I'm not really preparing this for final assembly right now because there are some significant sub-assemblies that I need to focus on before I think about final assembly of this robot quite yet. But I want to at least make sure this stuff is plausibly going to work. Whoops. those down a little bit. Oh yeah, that's going to be fine. So the goal here is to let one end of this kind of move around a bunch without pulling on all the circuitry this is connected to. Ken is asking what the take-up mechanism is for the cable. Well, I'm redesigning part of that, but basically a spool, like a spool on an axle connected to a motor. So, does that answer your question? Let's see how well this fits on the carbon rods before I declare it completely done. That needs to be loosened before it'll fit on the carbon rods. Oh, split braided sleeving. That's an interesting idea. I also might just take off the crinkle entirely. Like, I already loomed this stuff with gaff tape, and maybe that'll be fine. Alright, so I just slid it down the carbon rods, and I'm just tightening the screws that go between the PLA pieces with the little Ninja Flex core hugging the wires inside. Oh yeah, that's great. You could totally hold this thing by the wire even though you shouldn't. Okay, I think I'm happy with that piece. Next. Let's take this apart for now. To be fair, I did have to shim this with a little bit of tape. I think it would have been a little too loose if I didn't have the gaff tape inside, but honestly, gaff tape makes a pretty good grip surface against the Ninja Flex, so maybe it's just a good idea in general to wrap it with some tape right where I'm planning on gripping it. I mean, I guess it's up to you whether you want to declare that as cheating or whether anyone cares. And then that should actually just come right off. Probably easier to take these out separately and then the BNC. Ow, the center of the BNC is sharp. Okay, so I can put this cable aside. Yeah, I don't like that crinkle tubing. It's just, I mean, I use it because it's cheap and it seems to be something I can wrap my wires in so that the cat won't eat them. Because he doesn't like it either. That's the great thing about it. It's cheap and unappealing, which is what you want in this particular circumstance, but maybe not in this particular circumstance. So yeah, perhaps I'll just stick with the gaff tape unless I find some braided stuff that's particularly nice and won't cost a fortune. How fully do I have to disassemble this to get this apart? Probably more than that. Oh, and I like how these pieces are identical. It certainly helps to just be able to click print multiple times. I guess I'm just discovering the joys of manufacturing for small but larger than 1 values of n. That's certainly a thing. Maybe it's time to be servo AF again. Okay, so this piece, I think I'm going to declare that successful and put it aside. So I want to spend a little bit more time with this one. I looked at this one briefly, but let's see if we can actually fish the wire through using this new method. So I got this suggestion to pull the wires through using this little sewing implement called a loop turner. And this is used for really thin straps where you're sewing something together and making a little tiny tube, and then you've got to turn the tiny tube inside out. So It's designed to go through things that are maybe not quite as stiff as this plastic, but we'll see if it's flexible enough. The cool thing is it has a little hook at the very end. That should grab onto the thing that we're trying to pull. Oh, James suggests trying to spray the cables in something that tastes bad. I actually tried that first before I found out that the crinkle stuff worked so well, and it just didn't last very long. And the cables that he liked chewing on, he would still chew on them, even with that stuff. I had to just apply it really frequently, and then I just ended up with like extension cords that were always like covered in this gross, sticky orange. The crinkle stuff worked way better. He doesn't like that. In this particular cat's case, that was a good solution. He's picky about cables though. Like I've mostly had trouble with cables that are thick and juicy, like big extension cords. He really likes DVI cables. I can't have DVI cables around here anymore. How do you open this? Well, so much for those instructions. All right. That's what YouTube is for, right? Careful unboxing. That is stuck on my pants. All right, let's see if we can replicate this using the loop turner. So this channel is actually pretty thin, because I really wanted this area right here that would be kind of having to hold the knot in the paracord. I wanted that to be really strong. So this is printed with a really thick bottom that's totally solid, and then the rest of this has pretty normal infill. So this bottom plate is actually what's holding most of the load there, and it's forming this kind of load-bearing ring between the knots here and the carbon fiber clamps. So let's see if we can even get this through. I think we want to put this in. Will you focus? Oh, is this gonna be too big? Oh, yeah, I think this hole is too small for this. I think we're gonna have to use my other method. Okay. Servo AF, you're not doing too well today. Yeah. And, I mean, I could potentially get it further if I went in the other side, but I think it's just going to get stuck in the same place. So, alright, that will have to be for less extreme cases or for more flexible materials. So, the way I got this in before, which I guess now I'm going to have to replicate. So, I think I used this wire. And you can just fish the wire in through here. And that isn't too hard to get through. And then oh, I guess I already put it away. I used another piece of string. do this slightly differently. Okay, so I have this thinner nylon string. And I'm not actually going to leave this together right now, but I'm just going to do this once for demonstration, just to prove to you all that this actually works, despite how improbable it might seem. So, pink cord going in that side, and carefully backing this out through the same hole. And I did this backwards, actually, so I'm going to have to pull this completely through. The way I did this last time was I took the paracord, removed some of the inner threads to make it thinner at the very end. Okay, and actually I'm going to do this the other way around. Okay, so I want this string to go in on this side. So the hook's got to go in. Then I pull the pink string through, all of the pink string, not just a few of the threads. Great. And then I can take my paracord with some of its internal strands shaved out. And then the way I did this before was to actually pass this through that. But now I've got a loop, so maybe this will be slightly different. Maybe I do have to pass. The way I did this before is instead of having a loop here, I had a single string, I passed it through, and then I taped it back onto itself. And the tape was a weak point that was annoying and didn't actually hold very well. Maybe what I do here is, well, actually the loop is fine. I could maybe pass the loop through the end and then pull it back through with the wire. I'm looking for a little screwdriver to open up a hole in this now. Oh, actually a multimeter probe would be perfect. So punctured a little hole in the end, past where the cords are gone. Now I need the wire tool. Now I can pass the wire tool through that hole. Man, this feels like functional programming. And then I encapsulate that wire in a closure and return it by value. Oh, did I mess up my hole? I did. I guess I was a little too rough with that one. I could also just try pulling this directly with the wire. Why did that work so badly last time I tried that? I guess I gave that another shot. Let's remember why that worked so badly. Okay, so let's see if we can do this again. Maybe this time, make a hole, and just drag this back by that hole. Isn't this going so well? I thought so. I mean, my backup plan was that I could just put the pink strings through and then use those and then tie them to some of this, but the paracord actually works really nice once you've got it in. It's just really annoying to get in. Yeah, maybe this was my problem. How did I attach that last time? Oh. No. This is what I used before. How did that work? Let's maybe get a cleaner end here. I'd also come back to this because, like I said, I don't really need to do this right now, and I was just trying to show how my technique was totally a thing, but we can suffer this particular pain later. Yeah, let's work on that later. I mean, clearly the easy way did not work, and I know it's possible, so I'm going to move ahead and do that later. We can work on some more preparation work before we get too deep into that. So, yeah, and this piece needs a little bit of cleanup first. Just take off this hard edge a little bit. And I think I'll clear out the holes for the carbon fiber rods and the screws with a power drill. Those edges might be easier with an actual knife instead of this dull thing. Oh, that cat says, can you maybe knot the pink string around the end of the sleeve and pull that? Maybe that's what I did last time. That sounds like it's a good idea though. That's probably better than whatever I did last time. I think I just got lucky with passing the pink string through a hole in the end of the paracord sleeve, and somehow managed to get that through without unraveling it. But yeah, that's a good idea. Let's try that next time. I'm not really sure when I should thread it. Like, what I should probably do is, I've got this big spool of paracord. I haven't actually portioned it out into separate pieces for all the winches. I should probably just do that and then attach those separate pieces to this robot pretty soon. And then I also need to design the, well, I was probably going to design a simple 3D printable ball bearing pulley, since I didn't see something ready-made that was a reasonable price, that was kind of just what I wanted, and it was something that was pretty easy to design. So, oh, that's annoying. Ridge. I don't know if I'm going to be able to get that entirely off. That's where the build plate bumped a little bit. And I noticed it when I checked on the printer later. Oh yeah, James asks about the cuts on the side, if there's some kind of expandable hole for the carbon fiber rods. That is exactly what they are. Oh, this works. It's not really in frame, is it? Oh, there's a hello in YouTube chat. Hello back. This piece is not of the utmost aesthetic importance. I mean, I don't know how important it is that any of these pieces actually look good, but there's some things that I like about making it look nice, I guess. But this piece is sandwiched between two black structural pieces, so you'll see a little bit of the blue through the side, but it will not be especially prominent. Okay, let's take care of these holes. I think this 5/16 drill was about the right size for the carbon fiber rods. Yeah. Gotta be careful with these, because these need to be able to have enough clamping force, so making this hole too big would be a problem. Just trying out this drill bit on this piece of scrap plastic to see how the fit is. Smooth hole. And the rods. Let's see. Let's use the correct end. I should really label which side of the rod is the top. I started needing to differentiate them because they're the two ends. Like each rod has a slightly longer or slightly wider end and a slightly narrower end. Okay, so that's the end that I'm going to be putting in the top, and that's the drill bit that I'm using, and that's a nice tight fit. That will need additional loosening, so that's a good place to start. Cool. And then the other screw holes in this piece are not really that critical, so I'll just use something that's about right. I think they're all M3. Oh, these drill bits are not metric. I guess an 1/8 inch is probably close enough. Yeah, that'll be a nice loose fit for an M3, which is what I'm looking for here. Okay. So 1/8 inch and 5/16. right. I could actually do this on the drill press. That might actually be smart. Doesn't seem necessary though. This is going to be, well, yeah, actually let's do this on the drill press. I think that'll help. It'll be nice if these are actually straight. I'll make a little room. Oh, it just needs power somehow. Sorry, lamp. I guess we can plug it in over here again. Okay. Drill press. Oh, okay, servo AF. Come back. Nope. That's not going to be a good shot, is it? That's a better shot. Nope. Oh, that grabbed the drill. I was hoping for a straight hole. I don't know if that's going to be my outcome here. It doesn't look half bad. Do I have a better clamping solution for this? I mean, if I clamp this, I'm not going to get really any kind of centering on the existing hole. It's left a nice big chunky bunch of gook at the top of the hole. The rest of it seems potentially alright. Oh, can I crank the speed on this drill down anymore? Maybe speed is the problem. Oh yeah, this is way too fast. Oh, I'm sorry, you have my back of shirt cam. Oh man. I forget how this part works. Oh right, there's a release for the motor. And yeah. There goes first gears. Much better. Slow that down. Yeah! Alright. Should have been there from the get-go. Yeah, much better. Just cleaning out the gunk from that first hole, the melted plastic from going too fast. Much better. Okay. Just clean out this other hole. Zoom in for this one. Didn't go all the way to the bottom. Cool. That does it for the carbon fiber rod holes. Let's do some of these M3 screw holes. Just me, or is that drill bit warbling? That's fine. Till if it got all the way to the bottom. That would have been, yeah. think I did. Let's try the other one. Okay. There are two more that'll have to do with the hand drill. Ooh, drill bit's hot. Skin cells. All right, same drill bit, but this time I'm going in through the side for the clamping holes. Probably don't need the safety goggles for these, but you know. So this is a strange angle. Try not to do this directly into my hand. And maybe in forward. That was it. Let's do the other side. You can feel the resistance increase substantially when you get past the end of the actual screw hole, and it transitions from just like clearing out the hole to actually making a new one. I meant to do that. Let's clear off the gunge. Gunge I created with the drill press. Going way too fast. Gotta zoom in so you can all see the carnage. I don't know why the drill has such a low frequency PWM. I mean, you can ask DeWalt what they were thinking. Ew, that's melted right in there. So the really functional part of this that I still need to test are these carbon fiber clamps. I need to make sure that they actually hold and they aren't impossible to put together. That fine balance between will never go together and falls apart by itself. And this is significantly different geometrically from the other carbon fiber clamps. I mean, it's basically the same shape I used on this other piece, but this was pretty simple. It was uniform thickness and much thinner in general, whereas this is chunkier and kind of not so uniform. Like the bottom of it is really solid and the rest of it is kind of weirdly shaped and has less infill. The clamping is still kind of in the middle, which I don't know if that was the right place for it, but that's where it is. Oh, that's a pretty interesting response from that cat in chat who says classic iron core-based DC motors often don't work well with high-frequency PWM. They use a lot of the momentum. They lose a lot of the momentum they get when driven with low-frequency PWM. They lose a lot of the momentum they get when driven with low-frequency PWM. Okay, so like relative to what they would have with lower frequency PWM. I see. I guess that might be because of the motor core inductance. Or not the core, but you know, like its inductance in circuit with whatever windings are connected. Cleaning up after 3D printers. Let's see if any of that works. Oh yeah. So that's pretty easy to get in, but not loose. Similar story over here, a little tighter on this side. Let's put in some fasteners and see if it will fasten. So, are we gonna have to ask the CAD model what goes here? We might. I forget what fastener that's supposed to be. I mean, which length of M3 screw, really. And we haven't been to the CAD model recently. Let's take a trip there. It's pretty fun over in the CAD model. Alright, so this is the entire robot so far. Well, the entire flying portion. So this is a stand-in for where the camera goes. There's the actual gimbal mount at the bottom, and then our stack of LED rings. Carbon fiber rod supporting it all. There's some power converters and a BNC connector and power connector mount. Some sensors, the micro, a little strain relief, all the sensors. So, oh, there's so much here. So we can start turning off some of this stuff. We can turn off the entire sensor saucer, for example. A lot of this internal stuff. There we go, the leash anchor. I'm just going to measure this screw. .25 millimeters. We can also take a look at the cross-section view, which I think is pretty cool. Go to section analysis, and I've actually got a plane here that lines up with one of these channels. Where did I put that? Yeah. Yeah, so well, my monitor just went blank, but I guess yours didn't. So here you can see the support for where the actual paracord comes in. So it's going to have a lot of force directed roughly along this wire, but also in some related directions. So this has to stand up to some lateral force. It has to... Mostly the goal here is to direct the force up into this knot, which we're capturing up against this ring of plastic here. You can kind of see this assembly. It's not really the best section for viewing it with. But yeah, let's see if this actually works. Oh geez, that was 25, right? Did I already forget the measurement that we came here for? Yeah, 25. I need to grab some of those from the rack. Oh, James says, how do you get it to print different bits with different infill? I didn't do that. There are ways to do that, like I think Simplify 3D, which is a really powerful commercial slicer program, will let you do that. I just gave it a really thick top and bottom, shell size. So like it actually made this really thick too, but it didn't really matter since it's so thin. It mostly served to put a bunch of extra layers of solid on the bottom. And then the rest of this was normal infill. And support material, I didn't enable support for any of this. Did I? Is that true? Yeah, support was off. I think even if support was on, I don't think it would have given me support in the channel just because of the angles involved. Like, I think it knows that that's a small enough bridge that it can make without support. Nice. So one of those goes in there. One goes in there. And then, right, there's a little spot to put a nut. I've got to actually clean that out too. I think. Is this brim? It's hard to tell. Maybe that didn't need to be cleaned out anymore. I think it probably works. I think it probably helps, I mean. So I think I can just drop a nut in there. Drop a nut in there. pushing object. Oh, that's what I'm looking for. A little screwdriver. Try to push that down to about the right level. Now let's make sure those actually go catch the nuts properly. Is that working? This part involves some alignment by trial and error, I think. It is not quite seated down in there, it looks like. When I look in through the hole, I can see the threads and it looks like they're lined up, but they clearly aren't quite lined up. Trying to figure out which direction I need to push it in. Is there something thin I can push down there to line it all up? Let's see if the other side is any better. This one maybe is making progress. Oh, now I see the nut spinning. That wasn't intentional. So I brace the nut so it doesn't spin. Did I make that channel way too big, or did the nut just eat through it? I think this is cross-threaded. Let's try this again. I'm backing it out in hopes that after I back it out all the way, I can continue to apply pressure such that it seats into the right thread. I don't think that helped. This might be a problem. Well, if I brace it just right. Okay, now it actually seems to be starting to clamp. But, oh man, if I have to put pressure on that to make it clamp each time, that's going to be super annoying. mean, this might be a reason to put just a drop of epoxy down that hole. Let's see if I can get the other side to that point, and then we'll see if it actually holds the rods. And this piece could be better. This is not quite grabbing on this side. Oh. I think it's a side-to-side alignment issue. I can use the screwdriver to help align it. That's great. I thought this was too big. I guess not. So yeah, I think if this does clamp all right, maybe what I'll do is I'll, with the thing assembled, just put a drop of epoxy on the nut and hope that it doesn't seep into where the bolt is actually in there. So I'll use some thick epoxy, and I don't think it'll actually have that much room to seep around the nut, but oh, this is also still not getting the threads yet. I don't know how much of this is my design and how much of it's printing errors. I don't know why that's not catching on the nut. Why is this bolt giving me a compile error? Oh, maybe I'm getting somewhere. Maybe not. Nice to just get that nut out of there in case there's a problem with the nut. That is definitely easier said than done. Wondering if I don't think I have any tiny magnets that would even get close to that though. if I should be trying to get it further in or take it out. It really looks like it's lined up. Let's try a different screw for good luck. The nut's just like wiggling there in its hole. Oh, I think that's it. Oh yeah, that's better. Okay, that one wants to tighten now. So let's see if we can get the rods on both of these. And that goes through like that. Oh. Yeah. That might be doing its job. Let's try the other side. I think this is the one that needs epoxy for the nut. Oh, this one definitely needs like a drop of epoxy. Yeah, I can't really tighten that side down, but the other side actually seems fine. So, okay. Well, let's do that little bit of epoxy and then put this piece aside and work on some other stuff. So I'm going to loosen these. Sure, asks no little needle nose pliers. Nothing that would fit in there. It's a really small hole. I don't have any, like, tweezers would fit in there, but they wouldn't be strong enough to grab anything. Yeah, the clamp seems to be all right. Okay, so I'm not really doing final assembly here. I'm assembling some sub-assemblies and testing how stuff fits together. So my goal here is not to actually assemble the robot today, but we're getting closer for sure. And my next step here, this could use a little bit of surface cleanup maybe. Does this clean up easily? Yeah, not super easily. I might have to use a different tool for that if I care. There's a bit of surface roughness, but that's going to be right up against another piece, so I don't know if I care. I haven't even cleaned that up yet. But let's mix up some epoxy and just dribble a little bit in these two holes and hope that helps us keep the nuts in place. Use this stuff that I had handy. This is the Great Plains 6-minute model epoxy. Oh man, I closed the window because it really cuts down on the background noise in these streams, but I might have to open it again. It's getting pretty warm in here. So these mix 1 to 1. I need only a smidge. Yeah, I'm going to open the window after I put this epoxy in, both for ventilation and for fumes and for heating. This epoxy doesn't generate a lot of fumes, also I'm not using very much, but it's still a thing. I can actually get it all the way down in there to the nut using the stick, which I think is what I need to do. Okay. That should be good. I'm going to wipe the top surface because I don't want epoxy on that joint, or on that interface. Oh, I totally just got something in my fingers. Oh, actually, there's something else I could have epoxied too while we're into it, but we can save that. It's easy to make more. Okay, let's put that aside. What else do we have? So, I think we got sidetracked in trying to clear out this piece. So this is the top cover that goes above that tie offering that we were just going into. And this is meant to hold some LED strips. So let's see if we can actually clear that off and see if it does in fact have room to hold LED strips. So how are we doing here? Hoping I could try to get this off in some collection of largish chunks. I don't know if that's going to happen. the weirdest stuff. This is the Protopasta carbon fiber fill PLA, which I used mostly because I was running low on the regular black PLA, but it's kind of weird novel stuff. It's hard to tell if it's actually stiffer, but it certainly has a weird texture. I wonder if that's any better with an actual knife. So this area is a channel for wires for the LED strips. I don't know if that actually is easier. With the screwdriver, I can just kind of scrape. I'll need to cut some little LED strips to test this fit with. So I have some strips we can trim over here. These were all pieces of, I think, like a 1 meter, 144 LED per meter strip. So you can see the ends where they had attached the wires. I cut those off because they were a little weird. And then I've got 3 of these strips that are long enough for the rings, so I want to make sure to keep those unaltered. And then I should have one shorter one that we can cut up further. So there's one for the rings. I should have a few more that are the same length. Yeah, so I think those are the ones we want to save. And this one should already be shorter. Just a little bit. Okay, cool. So then this is the one we can trim smaller pieces off of. So each of these are 7 LEDs. I chose an odd number because I wanted there to be a center. Scissors might be a little easier. So these have very little space between the LEDs. I'm trying to cut them right in the center of the pads so that we have a little bit of area to solder to on every side. One more. Alright, so we've got 6 to spare, which you can put aside. So, it doesn't really matter which direction we choose, like which side we choose to make the input and which side is the output, but we should be consistent. But for now, let's just test the fit. Oh, looks like we had some spam in the YouTube chat. Thanks for taking care of that, Piotr. That's looking all right so far. How does that look on the other side? Needs a little cleanup, but yeah. Yeah, so the idea is, well, I'll clean up this a little more, and then the strips plus all their associated wiring can really just get set into the back of here and kind of taped over, and then this whole flat assembly will just pancake onto the other relevant portions, and the wiring can go down toward the micro. So this piece is looking all right so far. This needs a little more cleanup. What else do we have? We can continue doing the cleanup on here, but there's also just so much more we could take a look at. Is my ADD showing? So here we've got the LEDs. Let's see, we already took a look at this piece in the last stream, right? This little bracket for mounting the sensors. This one is similar, but it's new. This is a mount. You can see it still has the brim on the bottom. This is a mount for, does this look familiar to anyone? This is an XT60 power connector. They're usually used for like model aircraft batteries, stuff like that. It's a little overkill for this application since the entire robot here is 12 volts at most probably a couple of amps. So it's overkill for current, but I wanted something much more mechanically sturdy than something like a barrel jack or even maybe a JST, so thought I would go with that, and I had a bunch of them handy. So the idea behind this connector, if that would focus, is I can mount one of these in this little slot, and I'll probably glue this in place with a little glue around the edge, and then the other end will be soldered onto the wiring harness so I can plug that in. These are slots to hold DC-DC converters, which we'll get to in a sec. And then this thing. So that is my plan for how to hold on to the really tiny SMA jack to BNC situation going on with the camera's output. So the camera has a connector kind of like this one, an SMA, except instead of this sort of cable, it has a really thin cable. So my idea to actually make that manageable here was, if this would focus, so the camera would attach to a little coupler like this. That whole thing would fit into this hexagonal hole. And then up here, I can screw on an SMA to BNC coupler. And because that's hexagonal, it'll actually hold that so I can tighten against it. Now I've got a place to plug in the leash, which has a BNC connector for video. And then that's both a mount and a strain relief and a coupler. And that'll be right next to the camera. So I'm pretty happy with that. And then this also seemed like a convenient place to stow the DC converters, since that's where the power is. Could wire them directly in, maybe with some poly fuses, and then send off 5 volts and 12 volts to the various places on the robot. So then the other mechanical piece, so I want to clean this up, but there are a couple of other things I want to check the fit on. I know that's good, that's good. There's also, well, there's this interface where it grabs onto the carbon rods. This is basically just a copy from one of the other layers. So the parameters that I decided on are that it comes to 2 concentric circles that are, like the outer one comes to the same, the outer one is tangent to the carbon fiber rod. The inner one is a millimeter apart from that, so it's a millimeter at the thinnest there. And then I actually cut away a 60-degree arc from that to give it room to open up a little bit to clamp on. It's basically just a copy design, so I'm pretty confident about that piece. But I have not tested these DC converter holders at all yet. So I think that means it's surprise mailbag time. the very least, we have a DigiKey package to chomp into. But there's a couple others that I kind of want to open up first to save the DigiKey for last. So, let's see. Is this going to be on the floor today? So, I'll take a look at this in a sec. I also have... Oh, this was in some other package. I guess I already unwrapped the outer package, but then this object itself seemed pretty interesting. So, I think this is a soldering iron. This is something that I'd seen several people speak pretty highly of. It's a inexpensive but nicely made DC soldering iron kit that you can get from a few places. I think it's called the TS100. Let's take a look at this. Yeah, TS100 B2 mini soldering iron. Let's get some Servo AF. Designed by eDesign, made in China. Important safety. And the iron. Let's see what could be so important. So we've got a little Allen wrench and some screws. Hey guys, please register. Looks like I've got a number that all of you know about now. That's cool. Got some firmware update instructions. So those are replacement set screws for the soldering iron tip, it looks like. The input is DC 12 to 24 volts, which is pretty awesome. People often run these off of laptop power bricks. I could probably also run these off the power bricks that I got for Tuco Flyer. So that's pretty neat. I don't know which of these were important safety instructions, but sure. I guess it probably implies that you shouldn't just hold it by the tip, which is important safety. Oh, nice. Well, let's put this on the desk. Oh, very nice. Len has the most important safety tip. Do not apply hot iron to cat. I agree. Yeah. Have been pretty easy to avoid that so far. I did have some close calls with hot glue and cat. He insisted on hanging out while I was doing some hot glue gun work, and I hope he learned his lesson. Alright, so set screw. Oh, this feels nice. And let's see if I can use one of those Tuco Flyer power bricks. Is 2.5 amps enough? Seems like it. I mean, this says at 24 volts, it draws 65 watts. And this is a 60 watt supply. Well, maybe I don't run it off of this just yet. It would probably be fine, but I don't really want to risk blowing out any kind of protection in these just yet. I think I'll let my motors do that. I've got a barrel jack adapter for my bench supply here. I'm just gonna dig out that. worried for a sec because I saw some bite marks on the cable and was like, oh no, is that like my soldering iron lead or something? No, it's just a USB cable. At least Tuco doesn't have expensive tastes. Does that not fit? I don't think that's the same plug standard. That's like, I forget what the numbers are, but that's the wrong inner diameter on the plug. Okay, fine. Let's try the Tuco Flyer power supply. I think it'll be all right. I mean, assuming the plug even fits. This is one of the power bricks that I got for running the winch. This looks like a thicker pin. No? Alright. Great. Well, maybe that doesn't fit either. Well, maybe I have to hunt around for some connectors before I can power this effectively. Okay, well, I'll do that later. That doesn't make a good mailbag. I can fuss with the soldering iron at another date. Right now, let's get on with things. What are things, you may ask? Well, that's partly what we're here to find out. Okay. A couple other small ones. Oh, neat. Piotr says the iron has an STM32 inside, which is pretty cool. And Mitch says that the tips might be interchangeable between this one and the FX951, which sounds pretty neat. Oh, just some electrolytic caps. I have some of these in my DigiKey order too, but I ordered these from eBay a little while ago because I just wanted to increase my stash of electrolytics, and I had some in smaller sizes, but these are 1000 microfarad, 35 volts, so good object to have around. And I'll need some of these for the motor driver power supply on the WinchBot, but I also just want to have more of those in my lab. About this package. Yeah, okay, more capacitors. I think I ordered these at the same time. They came from a different place. Ooh, yeah, these are Nishikon 3300 microfarad. Yeah. So one thing I'll want to do with the WinchBot, I've been working on, well, one of the unresolved problems there is what to do with the energy when the motor slows down and that energy flows back into the power rails. It's got to go somewhere. If it goes right back into the power supply is going to have a, well, it's going to shut off the output and wait for us to reset. So that's not going to be happy. Oh, I need a place to put these now. So there are different strategies of different levels of complexity. The thing that seems to be simple and probably good enough is to basically just dump that energy into a large capacitor and use it for future locomotion. So not necessarily just dissipated into a resistor or something, but stored in a capacitor, and design your circuit with the ability, like, with some tolerance for a higher working voltage. So let's say you normally run at 24 volts. Now you stop the motor, a bunch of the energy flows back through the diodes on the motor driver into the power rails, and now you're raising the voltage of that storage capacitor a little bit. I'll have like a Schottky diode to keep that voltage from going back into the input power supply. But the trick is I'll need to make sure that, given the maximum amount of energy I plan to store this way, I don't raise the voltage too much, like above what any of the components on that side of the circuit can handle. Otherwise, like, if that is possible with this arrangement, and I think I'll probably just test that, like try to spin up the motor pretty fast and then stop it and see how much I can charge a capacitor. And if I need any additional circuitry, then, I mean, there are protection diodes that might work, but the tricky thing with protection diodes is they don't just turn on really suddenly. They kind of have a soft turn on. So I might need something active that actually measures the voltage and then turns on a protection device of some sort. Lynn asks, can I route the current to a tea kettle? Well, yeah, effectively that's what you do with a big power resistor or something. But the routing is the part that gets tricky. It would be nice not to need any active circuitry to do that, because that's just another thing that I have to add to this. I hadn't really planned on designing like an actual PCB for this robot or anything. It's basically just a eval kit and some like eBay and Adafruit modules wired together. Ooh, it is getting warm in here. What is this? Boot source. These are, oh, EPROMs. These are, there might be other things I use these for, but I got these mostly to try replacing the PROMs in that Tektronix signal generator with EPROMs. So I have a few of the same kind of EPROM that it uses for its data memory and program memory. So these are 27E512s, and these are 27C020s. There's a few of each of those. So I thought that would be cool. I don't know, I find that little test signal generator really charming, and I'd like to try backing up the EPROMs on it, just to have a backup of it. And it would especially be nice to, I mean, they're not socketed, so I'd have to desolder the PROMs. And then if I'm desoldering the PROMs and backing them up, it'd be nice to try experimenting with it. I don't know, I think it'd be cool to both back up the original software from that generator and have like a fan hack that does additional things. Like, it'd be nice to accept titles over a serial port. It'd be nice to, you know, try making like a game or a demo on it or something. I don't know, that's just a piece for a potential project in the future. We have one more kind of random one, and then we have this big DigiKey one that everybody's waiting for. This is another Amazon package. It might just be cat food and socks. Oh, close. I needed some of that. I have all the other good adhesives, but this was another recommendation. I'm spacing out on who recommended this, but somebody recommended this over Twitter. So I have a good supply of E6000, which is kind of a similar, like almost rubber cement sort of glue, but I've heard good things about this stuff in terms of how sticky it is. Contains toluene and petroleum distillate. Yeah. Ooh, for skate shoes, they have another product. Okay, I'll have to add this to my adhesive arsenal. Okay, I think it's DigiKey time. Toluene, yeah. Got all this good stuff for Tuco. So, I'm actually gonna have a bunch of things in here. I made this DigiKey order initially because of actually a challenge from I think if I'm pronouncing it right, Andrew Zonenberg sent me a circuit board that he designed. It's like a rework capture the flag. So the idea is it's a circuit board with a bunch of things that you're supposed to change. So traces that aren't routed, pads that are missing, differential pairs that are swapped, crazy stuff like that. And so I've done a little bit of that sort of PCB surgery in the past for reverse engineering projects, but that definitely seems like a fun challenge, and it's done stuff that's more intense than anything I've done before, and so it'd be an interesting challenge. So he sent me one of the circuit boards that he has for that, and this bag has all the other parts for that. It also has a lot of other odds and ends that I needed, so let's see. Oh yeah, okay, and these I think might actually be the capacitors we use for the winches. You'll notice there are 4 of them. I didn't get extras on these because they were a little expensive, but some nice capacitors for storing all that extra energy. Yeah. 4,700 microfarads, 63 volts. These are like what you'd find in a power supply. And these were actually rated for pretty long life, so nice that DigiKey has all the parametric searches for that. Vishay BC. Interesting, I don't see a normal like degree centigrade rating on here. I forget how these were actually marked up, but they were, like, I'd have to go look at the data sheet to see what the actual lifetime spec on it, but it was definitely higher than normal for this type of capacitor. So those will be fun. Those are definitely WinchBot parts. What else? Oh, this had a... DigiKey has all these delightful bags. So a few other odds and ends, some power resistors, which also are things that I kind of wanted in general, but also might be useful for WinchBot. These are 1.5 ohm, 25 watt. I don't know if this is exactly the value I'm going to need, but it was my best guess at where to start. And the reason I thought I might need this is as like a series resistor in line with the Schottky diode that I use to charge those capacitors. That would act as an inrush protection for the capacitors and as a current limit for the motor during normal operation. So I think the idea of how this might work is that you just basically charge the capacitor at all times through this power resistor. The motor can kind of take surges of current directly from the capacitor, but if the motor drains whatever is available directly in the capacitor, then it starts to draw through this resistor from the power supply, which might just be too inefficient, but it seems simple, and so I thought it'd be worth a try. We could also add some active circuitry to bypass that if necessary, but I thought I'd try the simple thing first. Ooh, these look like they're parts from Andrew's challenge. These are 0201 surface mount jumpers. I think these are in the kit just because they're so tiny. The goal was to solder them by hand. Let's take a look at them maybe. So this is a pack of 100 on this little strip. And these are just 0 ohm jumpers, so they look like resistors, but they're just pass-through connections. Oh, they're huge. Can we even focus? Yeah, cool. Let's see what these look like under the microscope. I'm just going to take one of these out so we can look at it. Okay, I didn't lose it, but maybe the camera did. There it is. Yeah, it's not. I could imagine it being worse. Let's try the microscope. Let's reset this first. There is a top side and a bottom side. I don't think there's any numbering, but there it is, 0201. Yeah, that sure is a little thing. So I don't have the circuit board yet. That'll probably be in my PO box this week, but yeah. It's tempting to try sticking this down to something right now. But let me go through the rest of my DigiKey package. Let's just put this back in this bag where I'll inevitably lose it. Alright, so that was an 0201 surface mount resistor. What else we got? More stuff for Andrew's board. We've got some capacitors, USB connector. Oh. Oh, these are even smaller. 01005s. Wow. Okay, I think these are half the size that one we were just looking at. Let's look at these under the microscope without even opening the package, maybe. These will be fun. I'm gonna wait until we have the circuit board before even trying to mess with these. That looks fun. I'm very grateful for the micro soldering tip. I think without that tiny soldering iron, this would be harder. At least assuming you're doing hand soldering instead of reflow. Yeah, that's cool. Have some semiconductors. So this is a multi-output LDO, the kind that you might use with an FPGA. Generates 3.3, 2.5, and 1.2 volts. And it's in a 16 LFCSP package, which sounds dreadful. I'm going to open the moisture bag and let's take a look at this. Oh, that's not too bad, actually. It's probably not too much worse than like a QFN. So that's the voltage regulator. Thermal pad on the bottom. I'm not going to take this out of the package yet because I only have one of them. A few more chips here. 74HC04. These were in the kit for Andrew's project, but I also got a few more because these are just super handy to have around. So I got a few more of them. Same with the flash memory. There was a flash memory chip in there, but I got some additional because they're super handy. LEDs. I don't think these are especially small. These are 0603s. I think these are how... So in this challenge, as you modify it, there's an FPGA on it that actually grades it as you go. And I think it displays your score on these LEDs. Or displays at least part of what calculates your score. These are pretty normal. They're just 0603 LEDs. Oh yeah, beer. That might help. I'm out of beer. I should definitely fix that at some point. What else? I got some more foil bags. FPGA. Oh, yeah. A single FPGA in a bag. This is a Spartan 3, I think. XC3 S50A. It's a really little Spartan 3. And I just got one of these because they're like 12 bucks each. And of course, it's a BGA part. Yeah, Spartan 3. So that'll be fun. Big old desiccant packet in there. And 74 HTT 245s, which are not for this project, but I wanted some of these to have around. I had some for Fade Candy, but I think I used up all the ones I had. So these are Schottky diodes. These are also for the winch bots. 40 volts, 3 amps, axial package. AKA big old chunky Schottkys. So all the power for the motors will flow through this in one direction, but not in the other direction. I'll put this with the motor supplies. What else we got? 1 megahertz oscillator, also for the challenge project. There's one of these. It's just in there, a little square thing. Hex inverter, similar story. There was one of them on the challenge board, but I got 10 because they're super handy. Just needed more logic chips around. And yes, these are for Tuco Flyer, DC-DC converters. So these are actually pretty nice looking. They're like, I think $4 each. So a little more expensive than the like RC hobby style DC converters you can get really cheap on eBay. But these have a lot of nice safety features built in. They have current limiting short circuit protection, and I figured I'd just use a few of these for the Flyer so that I could separate off the 5-volt rails into different supplies for the main microcontroller, for the sensors, for the LEDs. So there's the converters. Let's take a closer look at this in a sec. Let's put these aside. So I think everything else here is passives. We have 270 ohm resistors, 0402 size, and capacitors, also 0402. Great. So these parts will be making an appearance on a future stream when I have the challenge board in hand and some time to tackle it. Or whatever other metaphor. Tackle. What a strange word. And then all the rest of these parts are bot related or similar. Let's take a closer look at these DC converters. Come back, little converter. Oh, these are so cute. So these are designed to have a pinout compatible with the classic 7805. So there's a ground in the middle, input on the left, output on the right, if it would ever focus. There we go. So these are made by Murata. They had a CAD model online, so I'm about to find out how accurate that CAD model allowed me to make this. Guess it goes this way. Oh, there's a bump on the side of the circuit board here from where they punched it out of their panel. Cool. I think that was pretty solid. So, and then my plan was to have, I can solder and or have headers on here as I feel like. I think for some of this I might just solder wires point to point. I had those little plug-in breadboarding style headers, which are convenient, but they also have really, really little copper in them. Let's see what this is like with loaded up with converters. Oh, that does need some shaving on the sides. Yeah. Well, maybe I should mix up a little more epoxy so I can glue in that XT60 connector, because I wanted to do that, and then I can do some wiring to connect it to these converters. I think I might, well, after I make sure these all fit, which it seems like they're going to fine. So after I put these in, I might, instead of wiring these right away, I might actually build the little LED rings, since I think that's the next piece that seems like it might have interesting constraints. That one doesn't want to go in quite all the way. Nice yak shaving. Huh. Maybe. Again, hard to tell if I'm better off trying to get it off or forcing it further on. There we go. Oops. Ah, it sure does have the worms in here. Oh, Vince asks if the converters are all the same voltage. Yeah, they're all 5 volts. There we go. Oh man, it's like really hot in here and everything's getting really slippery. Oh, I hope I didn't just damage the board. I'm gonna have to look at that. I think I need to turn on the fan, even if it is gonna be loud. Okay, I think that's fine. Just knocked off a little bit of copper from the board, but it should be all right. So trimming the sides a little more. There we go. Okay, that'll do for now. let's try out the LED ring next, maybe. Seasons are pretty strange. We don't have very many of them here in the Bay Area. There's just kind of hot and kind of rainy, and you know, they blend into each other. I guess I used to live in San Francisco, and the temperature there seemed to change a lot just during the course of the day. It's a little less of that since I moved a little further east. Oh man, but I could actually walk to the convenience store and buy a cold beer. That's a thing I could do. Okay, let's put some epoxy on this and then put this piece aside for a bit. Oh, good question from David, who asks what the individual modules are for and why they're mounted in plastic like this. So, while the individual modules, mostly, it's not necessary. I could have just had one big DC-DC converter, but having some separation like that gives me some increased reliability. So, if I have a short on, say, one of the LED strings or on the sensors, then the microcontroller keeps running. So, I think I'm going to use one of these for the micro. Oh, so it is. One of them from the micro, one for, well, probably two for the LEDs, and then one for the sensors. See, the trouble with walking to the convenience store for a cold beer is it means I have to end the stream, and there's a bunch more stuff I wanted to do. But I guess I could just save that for the next stream. Okay. Let's get some epoxy on here. Oh, and the next part of the question was why they're mounted in plastic like this. The frame of the bot, everything's kind of held together on these carbon fiber rods that run up and down. So this is mostly just to anchor that onto there. And this one piece just happened to be able to anchor several different things. So the DC converters, the video connector, and the power connector. Helps to provide some anchoring for those big ol' heavy wires. Chris suggests I could just leave it streaming my cat sleeping while I walk. I guess I could. Probably get kicked off of YouTube or something. No, that was Twitch. Yeah, I don't know. I mean, anyone who follows the stream knows that I am fine at having a pretty arbitrary schedule. I guess the issue with this is I felt like I'd been working on a bunch of stuff this week to try to get all this, like maybe I was just trying to bottle up too much work and have it be one overcomplicated stream. I should have just done more simple streams during the week. Oh yeah, the laws that restrict when you can buy alcohol are super weird. I used to live in Colorado where I think you couldn't buy alcohol on Sundays. Need a mixing stick. Yeah, I don't know if they changed the Colorado Sunday alcohol thing or if it's still a thing. I don't know. I mean, I haven't lived there since 2004, but it was, I think it was a thing then. Okay, so I think here, I'm just going to put it part way in, and then, how am I going to do this without getting epoxy everywhere? I think I'm going to put it, because I don't want to get it on any of the conductors. I'm okay with it getting on the outside plastic a little bit, so. Let's not get that all over every finger I have. This popsicle stick is splintering all over the place. Okay, that should be plenty. There's only actually a little bit of epoxy in there, but that's all it's going to take. I just want to keep it from sliding out. And then that doesn't need any glue. That'll hold itself in just fine once it's screwed together. Okay, so this will need a little more assembly after the epoxy cures, but we can put it aside until then. All right. So what's next? So we can go back to this piece, but I think let's try spending a little time with this assembly because we haven't looked at this really at all yet. So we assembled a little bit of this. These are sections of the LED lighting ring that go at the bottom of the robot for kind of communicating with humans. And this is the actual mount that holds that onto the gimbal assembly. So very roughly, this shape you might recognize from the actual Feiyutech gimbal that we're using. That has a place for the carbon fiber rods to clamp on right above it with this piece. And those actually bolt together. And then this then bolts onto here with these three screws. So the idea here is you can have the gimbal electronics exposed if you need to work on it, and then just slide this whole thing down on top and then tighten these screws from the bottom, and that the LED assembly can all kind of be built around this frame. So this has a little bit more support material to take out. Oh, I've got some epoxy on my fingers. Cool. So yeah, I had to print this with a little support because I really wanted this ring to have some space to avoid all that gimbal stuff, and then these struts connect it back to the actual support for the LED rings. Seems to be strong enough so far. Cool. Okay, so now that the support material from there is cleared out, I can see if this actually fits where it's supposed to. So, these two pieces. Yeah, it's a tight fit, but it works. Just hangs out right around that. And there'd be various screws holding that all together. So I'm gonna try without that clamp piece, just assembling these to see how that fits. This will be another situation where captive nuts might have been helpful. Oh, good. I did design these to have a pretty tight pressure fit around the nuts at least. So hopefully that helps. So here, I think I can just thread the nut onto the end of a longer screw. And then just press that into place. And then unscrew that. This will be partly to test the fit and partly to actually line up the nuts in their little homes. So M3 by 10s, I think, were my choice here. Most of this used M3 by 10s where I could get away with it. That's a good start. Let's put in a few more of those. Just imagine there's a gimbal there. We could put the gimbal in, but it would just be in the way right now. This isn't tightened yet, is it? One of these is still loose. Yeah. Whoops. That nut just disappeared. So, okay. Some of these are all right. That one, the nut wasn't in the right place at all. This one, the nut is kind of not in the right place. I think the nut is slightly cross-threaded. I think I need to take care that the nut actually is pushed a little further down, or maybe there's actually just 3D printer garbage in the hole where the nut should be. I mean, I think the general approach is fine. I just need to clean this out a little more. Maybe it just wasn't in all the way. I don't think there was much 3D printer trash in the hole. Oh, nice. Mitch Johnson in chat has a 3D printer on the way to arrive on Monday. That sounds super fun. Yeah, there's so much that it opens up, so many new things you can start exploring when you can just print something that you designed right away. Huh. Some of these nuts might just have lousy threads. I might have caused that. Let's just take more care to seat these all the way in the hole, and then we'll try it again. Oh, I think that one needs some cleaning out. This whole bottom piece ended up a little heavier than I would have liked. I might have tried printing it with less infill, or, I mean, there isn't really much infill to speak of, but I mean, thinner shells on the inside piece maybe. That piece doesn't look like it's as in there as it could be. Different nuts seem to be a slight improvement. Okay, let's try that again. These nuts are definitely a place where maybe a little bit of flexible adhesive might help, like some E6000 or Shoe Goo. Yeah, because with this whole thing assembled, I don't want to be trying to, like, this will not be accessible, so I won't really be able to fish in there and get access to the nuts like I'm doing right now. That's better. Yeah, okay. That's a good fit. So 3 screws, nicely lined up. This is a little soft right there, but that's pretty expected because that's the side that doesn't have a screw, because that's where the gimbal is right there. But the rest of this is nice and solid. And that's not holding the weight of the gimbal, it's only holding the weight of, well, it's not even holding the weight of the LEDs, it's just holding them on there so that they don't slide, so that those screws don't have much weight on them at all. Okay, so that's ready for us to build some LED stuff on top of. These pieces don't really seem to need much cleanup. They can just go right on there. So I think the next thing to do is to electrically prepare the LEDs, and so that we don't have any nasty surprises as we're assembling this, I'd like them to be powered up the entire time, or not like the entire time, but I'd like to be able to keep testing them. So let's make sure we can just start piping some pixels through at least one of these LED strips and then build on that and start assembling it. Because the idea is we can just start assembling individual rings and then stack them together. But each of these is going to need power as well as data in and data out. So there'll be a decent amount of wiring. For the wires, I was going to use some of this stuff. 24 gauge silicone wire. This stuff is pretty nice. I just have one big spool of it, so I'll need to indicate the different signals with some heat shrink of different colors, but this is nice wire. It's thin and flexible, and it should be really good for attaching these LED strips together. I might use these servo connectors for ground, clock, and data, not for power. Haven't quite decided how I'm going to do that yet. Okay. So for getting this some pixel data, I can start here with this micro. Ethernet. And let's go ahead and solder some wires onto a small piece of this. Maybe let's just go with one of these. Okay, so I think I want to solder these to the back of the LED strip and try to get the wires to roughly come off perpendicular. And I'll need to do this on both sides, but I think I only want power and ground on one of the sides. I'm also realizing that none of these are labeled now, which is pretty annoying. Oh, there is a plus and minus. Okay, that's great. And there's an arrow. Okay, so this will be the input side. I'll solder wires to all 4 pins on the input side, and then on the output side I'll just take, I guess I'll just ignore power, so I'll take just the other 3 signals. Do I want to solder these directly onto servo connectors? Because that would make it easier to plug these together. It would definitely be nice if I had some small 4-pin connectors for these, but I don't really have the right kind of thing for that. Anyway, let's just do one thing at a time and solder 4 wires to this and get talking to it, and then we can assemble from there. So I'm going to assume this can just be one of the middle LED strips. These wires don't need to be super long. Just try to cut these to be a consistent length. Oh, I was watching somebody's YouTube video recently, and they had a really good trick for consistently cutting wires of a particular length with straws. Now I'm spacing out on who that was. Was it Tesla 500 maybe? Anyway, I should get a straw when I actually have more of these to do, maybe. So I'm going to set the automatic stripper to strip off only a little bit of this. And since it's silicone wire, it should stay that way. The wire insulation does not tend to shrink with the silicone wire the way some insulations do. Alright, let's just tin the LED strips, see if we can stick them together the usual. Oh, okay, cool. Linux says the straw thing was Fran. Cool. Yeah, Fran's channel is great. She had a video just today about an update about her project to recreate the Apollo, was it Apollo 11? It's this really interesting display unit that they used on some of the Apollo, like the flight computers. And it looks kind of like a 7-segment display, but it was actually electroluminescent. It's really super unique, and people have tried reproducing it using other technologies as props, but nobody's really been able to make the exact thing that they had, and so she's trying to do a reproduction of it. She's looking for a silk screener, if you know anybody who's good at technical silk screening. Tried to contact somebody locally, and they did not want her project, apparently. Sounded annoying. Oh, sorry about the hair cam. So I'm kind of putting the wire in the little semicircular cup that's left over from cutting the pad in half. I can inspect this under the microscope, since I know it's kind of hard to see here. These were a little too long, actually. I think it'll be fine, but next time I can make them shorter. Let's just take this to the microscope. Oh, David suggests scraping off some of the solder mask to make the pads bigger. That could be nice. Let's see what this looks like under the microscope. So yeah, I could actually just scrape off the back solder mask and solder to those 4 pads there. I think this might have gone all right. Well, I don't know. That does look kind of tenuous, doesn't it? Alright, let's try soldering them just completely to the back. I like that idea. And maybe we should just switch to microscope for this whole operation. Ooh, so many little tiny parts that I could knock off the desk. I'm going to have to do a decent number of these, so I'll want to find a technique that isn't super fiddly. This seems like it'll be alright, though. This is in the way. This is definitely one of the downsides of the really dense LED strip. It is harder to connect to at arbitrary locations. I did all the testing with this so far with the entire strip before cutting it at all, and so I could use the original connectors, but now I have no such luxury. Interesting solder mask on these. I wonder what it's made out of. I also should get a fresh knife blade, or at least a less dull knife blade for this. This one's better. Trying to ablate off that coating without digging into the copper, not being amazingly successful. Wondering if I have enough scratches in the mask here that some solder and flux might help take the rest off. Yeah, I think so. That'll be enough to solder a wire to. I don't want to linger there too long because of heat. I don't want to damage anything, but Let's try to do a similar treatment to the other pads, and then I'll do the solder, and we'll see how well that works. I don't need to do that for power and ground, but we'll need to do this for data to get access to that first LED. Okay, how about an actually fresh blade? Where's my blade repository? Ah. Ooh, look at that. Much better. Just tearing through the mask to reveal little shreds of copper. Wow, it's like a flexible plastic coating almost. Oh, I didn't just tear the copper, did I? I think I might be tearing the copper with that as well. There's another reason I'm happy not to be doing this to the high current pads, just the data. Okay, I'm gonna stick with that and maybe cut my losses. Ah, boogers on my iron. Oh, I should maybe be adding more flux to this. I'm just trying to arrange this so it'll fit through the hole in my plastic thing a little better. So that seems fine. Oh, that's terrible. Okay, okay. Yes, I know. Flux. Hoping this stuff doesn't make its way into causing problems with the plastic components nearby, but... Oh, much better. Much better. Ugh. Nothing holding that together but dross and luck. And a little bit of epoxy, maybe. Let's be gentle with that, but I think it's alright. That one's better. Okay, and here's where we start testing it. And when it starts testing correctly, then we start gluing and building on it, and generally making this mess more complicated. So, we should have 5 volts, ground, and 2 data pins. I think we determined that the level shifter was actually in fact not necessary for this, and that it's pretty happy on 3 volt signals, but we certainly need to power it off of 5 volts. Let's at least maybe tin the wires while we're here. Yeah, I think a lot of what I like about Fran's Disky project is, I guess, that difference between the nostalgia that people have from just seeing an approximation of the way something looked versus the nostalgia of an approximation of the way something worked, or even a complete replica of the way something worked. I think that, I mean, it's like, I don't know, I was complaining recently on Twitter. I mean, I don't like to complain about these things because, I mean, I don't know, I probably complain about too many things in general. But I was a little frustrated that there was like a CGA-themed game jam, but the extent of the CGA-ness was just the palette. And it's like, well, the palette was a lot of what people remember, but I don't know, it's like that thing that is a problem in a lot of contexts, where you take something complicated and nuanced and reduce it to the one thing that everyone recognizes from it. I'm glad people are making games. I guess it just makes me especially happy when I see projects that do actually look beyond just the surface level recreation, and, you know, like, there's something else that I like in that vein. I occasionally follow, I think it's in Seattle, there's a museum of telecommunication. They have a lot of really neat old telecom equipment, switches, and you know, just all the stuff that would have been routing telephone calls back before it was all digital. I just noticed that I made a face. Does anyone else see the face now? I don't think I saw the face before I had put the screws in, but now it's like clearly an underwater creature of some sort. It's, yeah, something like that. So ground, 5 volts, some power. Let's remember where the data goes on here. Oh, this was Tuco Flyer. Bot firmware. So we are looking for APA 102 clock and data, which is PD3 and PD1. So ground, PD1 and PD3. Let's use yellow for clock. It's PD3. Okay, there's the 3 pins we care about. We're also going to have 5 volts from the bench supply. So this 5 volt supply is just for the microcontroller. That's getting it online. And now this is ground, clock, and data for its output. I need some more power leads. Okay, that's ready for 5 volts. Really kind of want an additional ground wire here. Just use one of those breadboards. Now we have ground split to the power supply and to the microcontroller board, which will be part of the wiring harness when I do this for real. And then now I've got to remember which of these is clock and which is data. I can just try it, and if it doesn't work, swap them. I think clock was the one nearest ground. Oh, that also doesn't quite fit. Okay, this is about when we get to actually try the software side of this and get that part up to speed too. Because as I mentioned earlier, I had like several stages of in-progress rewrite of the software. Eventually I want this in nicely written idiomatic Rust, which I'm still trying to figure out how to do. So I have a terrible slow Python script and a terrible Rust translation of that, which is ugly and probably doesn't actually work, but we might be able to fix it. Anyway, I think we can apply power, and we should see nothing. 5 volts, 40 milliamps, no light, cool. Let's head to the Mac, where I have easiest access to the next set of software we'll be using. Okay, so far we've been prototyping the network connectivity on this bot using a Raspberry Pi. I think everything on the Raspberry Pi is going to eventually get moved over to a Windows machine, but it's been convenient for the moment. Cool. So I have this little repo that I'm going to update. Guess I already did that. Let's see if this builds. Well, first of all, let's try the script that we already did that we know works. So as for configuration, the Raspberry Pi has a USB network adapter up here that's on the bot subnet, the 10.32.0.1. The flyer should be on here as 10.32.0.8. Cool. So that's the microcontroller we have here on the desk. I should turn the camera back on in the the picture-in-picture. So yeah, that's the micro. You might be able to see the lights blinking as I ping it. Probably not, because it's actually spamming up packets continuously. If I run this old telemetry script, it should just continuously show me the data coming back from the robot. Most of these are not valid because the inputs aren't connected to anything. So that was just listening for packets on port 9024. We can do that just with netcat. And see the same telemetry data coming in. It's just spamming it out, it doesn't care if anyone's listening. And then similarly, there's a really simple Python script here for doing some LED animation. This is also written just in bare Python without any libraries or anything. It assembles a UDP packet with some animation that it calculates in that shader function, sends out frames. So we can try this for starters. So it's sending out frames. I still don't see anything on the LEDs, which might mean that clock and data are swapped. So let's see if that fixes it. Huh. What just happened? I just looked over at the power supply and it was rebooting. That was weird. So this is still sending out frames. The microcontroller is no longer on. Let's try turning that back on. Was that something I did or an unrelated problem? Huh. Okay, so we've got 5 volts going back into the micro. 5 volts for the LEDs, which I disconnected. Let's connect that back. So that's ground, still no current. +5. Now I've got some random lights showing up. There we go. I think I just had a bad connection on that breadboard. I don't know why I saw the power supply reboot. Did I kick a wire of some sort? I am going to turn up the current limit because the current limit on that LED channel is set really low. It's at like 0.2 amps right now. I'm going to set it to 1.5 amps. Okay. So it's running kind of slow. I mean, it looks okay, but it would look a lot better if it wasn't running at 20 frames a second. Oh, I just saw Peter's chat asking if that was Zoe Berg's kid. Yeah, that's about right. Let me try to reset the chat so it's not stuck. Oh, was that right? Why do we have more filth in the YouTube chat? Go away. Okay. So let's see if that straightforward Rust conversion of this actually works. I feel like that's probably not the entire chat because it looks like that cuts off in the middle of a line, but maybe I'll try resetting it once more. Ah, that seems better. All right. Blah, blah, blah. Okay. So let's see if the Rust version of this even works in the slightest. So it's still in this old directory because I've already been starting to replace it. But, oh, is it even here? Did I not check that in? Oh, maybe this file is only on my laptop? That would be annoying. this is the old code. I think there's still... Is this the commit that I want to go back to? Yeah, there it is. This is the file I wanted. Let's go back and rescue it. I have this. I've moved it. I guess I just didn't add it to the repo when I moved it. So we're going to go back in time a bit. And save that file for later. Is that what I wanted? Oh, I'm in detached head state. Just that. Oh, okay, that's what I wanted. Now I'm actually on a branch. Cool. So now I can go into this old directory where I was keeping all this junk and actually move my rescued LED tester rust into there. Okay, so again, we are on the Raspberry Pi. Let's actually set up SSHFS so we can edit stuff remotely using whatever editor we want, which in this case is going to be Sublime Text. Let's clear off a little bit of space here. Cool. Is that already mounted? Maybe it is, okay. Old lead tester.rust. So, I wrote this when I was just barely starting to read the Rust book, so I really did not know what I was doing at all. But let's see if we can maybe get this to work. So this is binding a UDP socket to an arbitrary local address. It's using this as our destination. We want to change this to actually be our winch. I was just using localhost for testing. 10.32.0.8 is the winch. Or not the winch, the flyer. Let's see if that compiles. Do I not have Rust on here? Really? I thought I had Rust on this machine. I guess we're installing it on the Raspberry. Can Rust up do that? This is the regular Rust up. So, yeah. Okay. We can look at this code while the compiler downloads. I thought I had already installed it on here, but... Oh, maybe I had already installed it. Had I just not logged in since updating the path? Was that the problem? Or was that just an old SSH? Ah, maybe that was the problem. Great. So bot controller, old. It's compiling that plain old bare Rust file. Oh, well that sure is fast. And it looks like there's an area at the beginning that's always white. Oh, that's really warm. That part of the board could use some heat sinking. Actually, this whole thing's pretty hot. So why is that first section stuck on? And is that showing up in our packets? Let's do a TCP dump. So some of these are telemetry coming back. So these are telemetry coming back from the robot. These are LEDs going out. Oh, what if we want to just set all the LEDs to like a dim gray color or something? Just for testing. Okay, so those all should be the same. So let's see if that starts at the beginning of the LED strip or if we still have a problem with pixels being stuck. Huh. So what's going on there? This does not make it clear where the UDP headers end and where the payload begins. Is this... Oh, beach ball, why? Okay, so is this UDP or is this is IP? These are IP addresses. This is a full IP header. Keyboard. port, length checksum. I think this is the beginning of the packet. Yeah, that's the command. So all the pixels should be identical. I don't know why we're getting stuck pixels. I think maybe the next thing to do is to check the SPI traffic on the scope to see whether it's a hardware problem. I mean, powering them up still gives me full bright on the first several pixels. It also might be a level shifter problem again. Maybe we actually need the level shifter. Well, let's get the scope out. Joys of incremental testing. Get to find the bugs sooner, you hope. Oh, good question from Mitch. Was it stuck with the Python script versus Rust? Yeah, let's go back to the Python script. I maybe didn't notice it then. Oops. The Python script. Let's add some power. Oh, that does not look stuck with the Python script. Okay, that's an interesting data point. Are we just discovering more weird failure modes that happen when you don't have the framing bits set right for these API 102s? What were we actually getting differently? Okay, maybe we don't need the scope for this particular problem. It would be nice to have TCP dump only give me the UDP headers, or the UDP body rather. Is this how this works? Those look like frames. There's the command byte, and then E1. Those look like pixels. Okay, what about with the Rust version? That looks really similar, but now it's stuck and it's going to get really hot. Oh, is that the problem? Looks like there's a 0 at the end, which I think that'll prevent the pixels from getting fully clocked through the string. That caught me up before. Problems at the end of the packet can cause issues with the LEDs at the beginning. Ah. That was me not understanding how ranges in Rust worked. Let's see if that fixes it. Like I said, that was something I wrote And I barely understood anything in the language just to see if I could get something working. Okay, it looks like the end of the packet looks fine now. We should have all dim gray now. No super hot bright packets, or bright pixels. Yeah, that looks good. Let's put the regular animation back now. That's an improvement. And much better frame rate. Well, since I've got the scope running anyway, and I don't have the code to measure frame rate in this with Rust, let's just measure frame rate on the oscope. I can show you the partially complete Rust code that I've got that is going to, you know, replace this, but that goes deep. I'm still figuring out. I guess a lot of it boils down to learning how to use kind of asynchronous programming primitives with the Tokyo and Futures libraries, and figuring out how to structure everything around that. Not like everything's going to be super asynchronous. A lot of things are just going to go on dedicated threads, but I want to, for sure, interoperate with that stuff well, because I'm going to be using some libraries that are built around that, like WebSockets and HTTP, and it'll probably come in handy. So I've just got one scope probe out. I'm just going to stick this on, doesn't really matter, 1 of clock or data. Okay, so there's a mass of data with not very good signal integrity on the ground right now, but that looks pretty speedy. So the frame rate's clearly varying. Yeah, it's like 500 frames a second right now. So let's add some sleep for now. Well, I mean, we could just slow down the animation, which might look interesting, but the speed will vary because it'll be based on the computation speed, which is also varying. But just for fun, let's just try slowing this down by a power of 10. Or a factor of 10. Sweet. Yeah, you can see they kind of speed up and slow down based on how many of those blips are on the screen. Where do we find a delay here? No, not that rust. Oh, not the core. I keep wanting to go docs.rs/standard. That doesn't actually go there. Docs.rustlang. doc.rustlang.org/standard. Thread. Yeah. I mean, I already have a slightly better timer than this, but let's just go ahead and do this the easy way. So it's thread, sleep, and then time duration. I think let's just try roughly 200 frames a second, or say 150. That'll be plenty. This isn't actually setting the duration between events, it's setting the sleep time. Okay, so it doesn't know what type the frame is here, and so by trying to convert an integer of unspecified type into a frame number, it's complaining about that. And I renamed this FPS. So let's specify a type for this. Let's make that I64. U64, sure. Oh, good question from Len. Will Tuco chase LEDs? Not that I've noticed, but I haven't had like a LED contraption set up that he would seem likely to chase, you know? Oh, I meant to cast that entire operation. So here, I wanted to do the division in floating point and then cast the result to be an integer number of nanoseconds. That's why this thing that you can't actually see is a little less convenient than it could otherwise be. Oh, this wanted a U32. Oh, and because I negated that, actually this needs to be a negative over here. I really like Rust so far. I'm still wrapping my head around a lot of the more complicated things that you can do with it, but it definitely seems to fit how I prefer to think about things. Ooh, that is super slow. So we've got a signal on the scope again. So as you can see now, it's kind of jumping around a little bit because it still depends on the calculation time. We haven't changed that. It's still It's still a delay plus the time it takes to calculate, but by making the total period longer, we're making the jitter based on the differences in calculation time a lot lower. So again, not a great solution, but totally fine for this level of testing. So I think that's all I'm going to do with this Rust-based test for now, but it is nice that we can run a much smoother version of this on the Raspberry Pi. So it's pretty straightforward code, just some nested loops, filling in a packet buffer and then setting the packet buffer. I've started doing something a little bit more idiomatic that should be a little nicer for doing kind of higher level things with this. So we can take a brief look at that, but then I'm going to go back to attaching LEDs to other LEDs. So source. So I'm still just barely figuring out how to organize all of this. I've got a library crate that has some bits of code that I'm going to end up using. So communication with the bots, gimbal protocol, WebSocket space control, LED rendering. I don't really have a whole lot in here yet. I was starting to figure out how the objects in the bot communication class should work out. Since some of it, I need to think about how objects are owned, what things might be done by different threads. Some of that is surprisingly easy to figure out later, though, the way Rust is designed. So some of it is just trying to think ahead enough to figure out what I personally want to do with this, but then figure out how that maps to the different Rust abstractions available. As far as LEDs, I've got this bit here where I was taking some inspiration from, there's this LED framework I made a while ago for Fade Candy in C++. Oh, this keyboard keeps losing its USB connection. So it has, here's the actual library. It has a few different kind of header-only objects here. It has this idea of an effect, which is something that is basically a shader that maps information about every pixel into that pixel's color, and then you can compose these together. So it's a bit of a functional framework for doing LED programming. It has some info that's per frame, per pixel. This layout for all the pixels usually comes from a JSON file that lists the coordinates of all the pixels in your thing that you're trying to animate. So I was taking some inspiration from this, but this is a lot easier in some ways in Rust, I think. I think if I use some of the existing abstractions, especially like iterators and futures in this, I can take the kind of composability aspects of this and make most of that just implicit to stuff that's already been designed by other people in the language, which should be nice. So I was trying to use some of the abstractions from, so the futures object, or the futures crate is pretty nice. It has some interesting abstractions called streams and sinks. So a future is a value that might be available later. So instead of a value that already has a value or already has either a value or an error, it's a value that might be a value later. And it has an interesting way of modeling the data flow between those components in such a way that the compiler can just reduce it pretty much entirely at compile time. It's really neat. And it has a concept of a stream and a sink, which are like a future, but they provide or consume data items. So you might see where this is going, where this LED animator probably wants to just live on a separate thread, and so you maybe call this function and give it some information about all the LEDs. You give it a sink, which in this case is, I'm probably going to change this, but I designed this to be kind of a multi-process queue that you could send completed LED frames into, and then a different thread would send them off to the LEDs. I've since discovered that there's a way that you can just take a UDP socket and send a copy of it to another thread. So the thing that I originally was planning on doing was just having the LED thread send those directly to the UDP socket, but then have a different thread handle incoming messages. So I think I can actually do that. So I've been trying to work toward that actually happening. And then trying to represent the inputs to this. So the animations will be running on a separate thread, but then you'll have some way of communicating what you want them to do. So the different LEDs in the system will have different LED info associated with them. So some of them might be winch LEDs, some of them might be part of the flyer, but then you'll also have a way of communicating to the animator, like, well, what is it that you want me to do with all the LEDs right now? So that's kind of what this animation mode and the shared state are going to be for. This is the thing protected behind a mutex that you can mutate from other threads, but the animator will just continuously use that as its input. So that's about all I'm going to say here. I'm really excited about this part, but I've still been just mostly reading a lot of code, reading a lot of documentation. Started to do a little work on the FY gimbal, basically just trying to make a Rust version of the library that I wrote in Python originally while I was figuring out the gimbal protocol. And this has been an interesting way to figure out, well, how do I want to do parsing in Rust, and how do I want to do like a network protocol? And so that's led into some interesting libraries to familiarize myself with. Just catching up on chat a little bit. I'm not really sure where the talk about expect came from. Was that in my little example here? Oh yeah, no. So this might be a little weird at first. So this is a function that returns either a value or an error. This is just a way of saying this is something that I, as a programmer, expect to always succeed, but here's the reason I expect it to succeed, and if it doesn't, then this panics the whole program. So it's like an assert, basically. You wouldn't usually do this except maybe during initialization or like in example code, but this is initialization and example code, basically. There's an idiom, I mean, there are various idioms for handling that in a nicer way. The simplest one is the question mark operator, which, do I have any instances of that? I don't know if I have any of that yet here, but it takes an error and propagates it, basically. I don't know, there's a lot I could get into here. I don't feel like I quite have enough substance to really do a proper stream on Rust, but I wanted to show at least some of the stuff I'm working on here. So, kind of getting my feet under me with Rust, but it's been fun so far. Such a cat. Oh, man. Okay. And this seems alright so far. So, let's see how compatible this is with my little ring. So, kind of like that. I'm being a little ginger with these wires, but just trying to get a feel for how this is going to go together. It should be fine. I just need to snake in a couple more wires for the data coming out of this, but let's see how this looks like with the diffuser on, maybe, if I can make that happen. I think I will actually have to pass this through the other half. Okay, just trying to make sure these are not going to short out or anything. think the beginning of this strip is quite seated all the way down as it should be, but that's going to be hard to do until I protect the wiring a little bit. Okay, that is not quite fully seated together. This is not actually that hard to put together. I'm just being kind of ginger with this while it's turned on. Maybe I'll unplug the power briefly and then actually put this together. I think it's the wires getting in the way. I think I just need to manicure them a little bit carefully. Ah, is that it? No, that's still not quite on. Okay, well let's just look at the side of this that is actually completely fitting together so that I can get a sense for how well it works before I fuss with the wires too much more. Give me some light. Try this with less studio light here. So it does reflect a lot of the ambient light, which is not bad. That is the thing. I'm looking at the monitor trying to frame the shot, but it's actually kind of hard to get a sense of the color from the monitor. So looking at this in person, I can still see some separation between the red, green, and blue diodes, but it's pretty subtle. It happens mostly when it's just red and green and no blue. But it does look nice. Like, it's maybe not quite as diffused as I expected it to be, but still pretty good. Yeah, that should be nice. This is pretty much doing what I expected it to do. This should be a pretty nice addition to my little bot. Nice if I can get this to close entirely, but I think I might try to reinforce the wiring before I get too forceful with that. I'll see what's going on in there. Maybe I can actually get this to close if I just poke it in the right spot with a non-conductive spudger. is that properly spudged? I think it's that edge. Need something thinner, but not conductive. Oh, is that it? It just acts like the tape is snagging on the track that it's supposed to be fitting into just a little bit. Maybe I can fix that with a knife. I think I can see the little piece of plastic. Oh, that's closer. Oh, is that in? Can't quite tell. It's definitely really close. I do actually have a piece that holds this together slightly, which we could put this on. Oh, this won't fit because the wires are not going into the right place. Okay. Doing that without the wires in the proper channel is just annoying. Okay, well, sort of like that. Let's maybe put these together a little bit more for real. So yeah, I mean, I could try other diffuser materials and keep fussing with that, but I think this looks fine, and I'm willing to just continue putting it together. I think I could continue messing with it, but I don't feel like it. I'm pretty happy with it. So, I need to do a little more soldering on this, and then I'll try putting together one complete ring and see how well that fits. Tuco looks happy. All right. Well, we could do some of that. We could also continue cleaning up this piece and seeing how well that fits. Okay, so we need some data wires coming out of this. Should also probably choose a heat shrink color scheme. And just use little pieces of heat shrink to mark these wires. Those fit. Barely, which means I won't need to shrink them. So red and blue for power, I guess. Now, I guess if I'm going to actually color code the clock and data properly, I should remember which one is which. And I already unplugged this. Let's plug this in again to quickly make sure I remember which one's clock and which one's data. It would also maybe be handy to solder 2 grounds on. I mean, I'm imagining having data connectors kind of going all over the place that are ground, clock, and data, and then a separate system, which is just 2-pin power, which means that on the input side, I want all 4 pins plus an extra copy of ground, and on the output side, I need 3 pins that can skip the +5, since I don't want to daisy chain the power. And it's pretty easy to add another ground, but honestly with these rings, I'm a little limited into how many wires I can fit in the area where the two pieces of tape meet. So maybe I'll save the... Well, actually, all the LED strips in this project, I'm a little limited in how much wiring I have right by the strip, so having grounds connected together elsewhere seems like the way to do that. Okay, this is the one next to +5. Is this data or power? Or data or clock? Backwards. Yay, good old LEDs. Oh yeah, something pretty satisfying about a little tiny piece of heat shrink like that on a silicone wire. Maybe I will shrink it a little. That might help it stick in a location that might be convenient. Okay, so yellow is my code for clock, and green is my code for data, and then red and blue will be power and ground. I mean, I have a lot of white silicone wire. Originally it was for a project where I wanted all the wires to be white for aesthetic reasons because, you know, a bunch of multicolored wires would have been distracting. But then you get into economies of scale, and like once you have a spool of white wire, then you start finding other ways to label the wire. Some output wires on this. Oh yeah, Tuco does look happy right now. Okay, let's do some more solder mask scraping. If I can build one of these rings that works, then I can kind of assembly line the other two a little bit and do fewer tool changes. So I don't know if I'll get all of these assembled on this stream, since I'll probably need to take a break at some point, but this has been working out all right so far. I'm just going to tape down that board, but my tape had a bunch of conductive debris on it. Conductive debris. Yeah, why don't we have like summer horror movies about conductive debris? I'd watch that. You thought your desk was clean, but just then, a particle of conductive debris makes its way onto your latest prototype and ruins everything. So, this copper seems to be really, really thin. I'm trying not to make a huge mess of it like I did with that one pad on the other end. I think I want to make sure that, well, so when I apply heat, it's going to start to really break down this coating, but I think it'll start to break down especially in the areas that I've been scratching, and I want to make sure that that causes it to break off in a pretty nice sheet, or at least to kind of move out of the way. I think part of the problem before was it ended up just kind of staying there and staying in the way. There's definitely some fresh copper up here. And then in the back there's kind of a mixture of copper and epoxy. Yeah, because there's that nice bright shiny copper, but then there's that like kind of yellowish powdery layer. I assumed that that was copper, or at least copper related at first. It might just be something that forms like right on the interface between the solder mask and the copper. Yeah, that's nicer. Okay. I was worried that that yellow stuff was like most of the copper, but I think that might just be some kind of interface layer, and the actual copper is a little thicker than I had feared. So that's nice at least. And kind of almost like just a blade off little chunks of it that come off intact. So it doesn't seem like it's bonded to the copper like really any better than your average solder mask. I think it might, I mean, I guess I'm chalking up the weirdness to mostly being a flexible, like a very flexible sort of PCB arrangement. But maybe there's also something weird they do about the solder mask for thermal reasons. I don't know. Or maybe this isn't that weird, it's just I haven't quite had to dig through a solder mask quite like this before. That's great. Kind of overkill maybe, but it'll be great. Mixture of copper and epoxy, conductive debris that you can't get rid of. Yeah, that's pretty scary. I mean, at least this stuff I can just like sweep it into the garbage. But yeah, if it was like wet epoxy on your board, then ooh, that would suck. Oh, that wasn't tinned. Let's tin that separately. And then flux pen. Because doing this without flux pen is just sad. You should have some nice possibilities for integrating this with other stuff. I mean, it'll have a little WebSocket server, and lots of things speak WebSockets. I was probably also going to include a little HTML server, or rather, you know, an HTTP server with a little bit of HTML content, so that you can just point a browser at it and control the robot. Which, of course, will only work on my internal network here, but would be useful there. And that might also make it easier to integrate with OBS stuff, since I've still been thinking about how to do the stream integration. It would be nice to do the streaming just entirely from Rust, but I don't think the library ecosystem is quite there yet. So I think actually using OBS is probably still a really good idea to actually do the streaming. But I think I'm probably going to end up writing my own OBS plugin to do computer vision in, doing point tracking and stuff like that. So then that'll end up being a client to the WebSocket interface on this bot server. And I don't really know what the communication between the WebSocket server and like the Twitch chat bot is going to be yet. I don't know who's going to be responsible for arbitrating between commands coming from different places, but it does seem like that's a job for the bot controller and its WebSocket protocol. And I'm assuming that it'll have a more direct connection to like basically an administrator joystick, like something that'll always move the bot around regardless. And that might be the Xbox controller attached to the same computer running the bot controller. That might be control boxes attached around the room over Ethernet. Like maybe I use another one of these little microcontroller boards to make wired Ethernet remotes. Well, that looks all right so far. So I can't really test these until I build another LED string to attach to the end of this one. So maybe let's do that and then test both of them, and then try to install this one into a ring. It's tempting to do some of these little 7 LED strips. I think those are going to be a little special though. Like I think those are going to be like magnet wire on the back side of the board kind of thing. So let's just do a second one of these 36 LED strips after I label this one appropriately. And for color scheme on the output side, maybe I'll have an additional band that I add. I'm missing a color. There's blue. Did I put this one away? I think I did. Okay, what else do I have? I have... oh, I've got white. White wouldn't really show up well on white wire. I've got clear, which has the same problem. Well, I could just put 2 small rings on the outputs and 1 ring on the inputs and use the same color scheme otherwise. Okay, green is closest to blue, or ground. So that'll be this wire, will be double green. And yellow. Yellow for clock. Doesn't yellow seem like clock? I think blue would have been better for data, but that would have been easy to confuse with ground. I mean, I guess green has the same problem. What I'm trying to say is this is pretty much arbitrary. All right. So let's put this aside and make another one, and then try to test both of them. So let's just do some solder mask scraping. Input side first. Yellow for sun rising and setting clock. Yeah, that sounds about right. Yeah, I mean, it seems like this, sunlight. Sunlight is a clock signal, isn't it? I mean, it's very spread spectrum. My approach with this is usually to kind of do crisscrossing patterns of kind of scraping one way and then scraping the other way, and then it'll start to kind of break off. It's really easy to cut too deep in the copper when you're doing this, at least on boards with thin copper like this one. So I'm not really cutting into the copper, I'm just kind of running the knife over the top of it, and sometimes just chipping away at bits of the epoxy that are loose. You might notice this one went a lot better than the first couple. It definitely helps to calibrate how a particular board feels. I think I was being a little too light in some ways and too forceful in other ways before. On the microscope, not quite entirely in focus. Len adds that color coding is important so the electrons know where to go. This is going to depend on what country you're in and like what the plugs look like there, but the plugs I'm used to from where I grew up in the US they often had a ground lead with a little hole in the end. And so, you know, it was like where they manufacture it, they have some, you know, some tube of material that they roll from some flat metal. So anyway, you get this thing that is a round conductor that comes to a point, and then usually there's a hole in the end. And I remember some conversation with my dad when I was really little, asking if that was how the electricity got through the plug. And then he explained, well, actually, that's the only place the electrons can't move around in. And my mind was blown. Yeah, if you ignore that yellow layer that I was worried about being fragile, then the actual solder mask seems pretty sturdy here. The copper under it is pretty soft, but yeah, I don't know what that yellow layer is. I'm just guessing it's some kind of oxide or some other like coating that happens. It's also tempting to give myself a little more room around the power and ground. I don't know if it's really worth the annoyance though. That'll be sufficient. It almost looks like a layer of Kapton. That yellow stuff, like polyimide tape. I wonder if that was part of the process, like they coat it in Kapton and then solder mask? Maybe it's like coated in Kapton tape and then dipped. It looks like it's a layer in between two layers of that black solder mask. Whisperfist asks if coaster melt would be powerful enough to burn away solder masks. I doubt it. I imagine that would take like up into these several tens of watts, which is a lot more than what you find in a Blu-ray burner. It's probably fair to say that anything that can ablate away this solder mask is probably going to need to be water cooled or something like that. I mean, you know, it depends on the duty cycle and how much you actually want to run it, but having enough power, yeah, I don't know. That'd be interesting. I mean, you could try coating a CD with solder mask and then finding a way to fire the laser. Yeah, it would be fun to continue on Coaster Melt. I had a fun time getting the project to where I got it, and then had a bunch of personal stuff happen and got distracted. Oh man, now I want a straw. To go to a diner or something and bring back an extra straw. Such cat. Okay, so 5 wires per LED ring, the way these are designed. 2 power, 2 data in, 2 data out. I thought I was going to be using Fade Candy for this one at first, because I thought I was going to be using a Raspberry Pi. But it made sense to use the AP102s for something that's going to be moving around a lot, since they have faster PWM. And if I'm not going to have a USB-based computer on there already, then I might as well just have my microcontroller send SPI frames. But I'm sure it takes an inspiration from Fade Candy where I can. So 1, 2, 3, 4, 5, 6. Silicone wire is so posh. Oh, I didn't flux this one yet, did I? Oh, man. Can you get YouTube copyright flags from people driving by with loud music in the car? Is that a thing yet? That does not look brilliant. Oh, it's a little better. That was getting a little too hot. I'm returning with tweezers instead of holding it by hand. Alright, that's fine. Yeah, soldering it on the back like this is much better than trying to use the fraction of a pad that's left after cutting this tape. Cool. Solder 2 wires on the other side of this, then heat shrink and test. is the YouTube chat. Oh man, we don't need we don't need spam asking for subs. Thanks, bots. Oh, and then we had a question from Carlos in YouTube chat who asks, what kind of LED are these? WS2812. They're similar to the WS2812. These are the APA 102s, which the main differences there are they take a clock and data line instead of having kind of a self-timed protocol. So they're a little more compatible. In this case, I've just got them running directly off of an SPI peripheral on this microcontroller. So that's kind of handy. They also have some nicer brightness control than the WS2812s. They have higher frequency PWM, and you can give them kind of a global brightness setting. Well, not global, but you can give them a per pixel brightness setting, which is shared between red, green, and blue, but sets like the overall current for that pixel. So that means you can actually get some nicer brightness dynamic range, and some of the dithering tricks and stuff that I used on the Fade Candy for the WS2812s aren't quite as necessary. It might be nice to implement some of that in Rust, though. I'm sure I've got the CPU power free to do LED temporal dithering if I want. Definitely got the frame rate. Ah, yeah, this definitely looks like a layer of Kapton now that I'm thinking of it. I was worried at first because I thought that might be part of the copper, but no, I think it's copper and then black epoxy of some sort, and then Kapton, and then another layer of black epoxy or conformal coating of some sort. It seems like they might be different substances. Like maybe the stuff underneath is harder and the stuff on top is softer. Kind of hard to tell. I mean, it looks like the stuff on top looks glossier, but that might just be because when I break it, the surface isn't glossy anymore. So in that case, this is less delicate than I thought it might have been. Yeah, that explains some stuff. Like in that first strip I did, there's this stage where it looked kind of like, you know, after I was partially scraped through and I was using the soldering iron to move stuff around while it was hot, I saw something moving around, almost looked like the pad had delaminated, but I think it was actually just this little square of Kapton tape. Alright, so no power on the side, just data out. Oh, good question from Blake in chat, who asks why I'm scraping the end here instead of soldering to the equivalent pads over here like I was for power. That's because these pads over here are actually not the ones on the end. These are kind of one LED down. So these are actually the end pads, and the power is all going to be the same, but the data pins go through each LED. So if I were to solder to these, then I wouldn't be able to use the last LED, or in this case, on the output side, if I solder to here, then this LED and the first LED on the next strip are going to get the same data, which isn't what I want. But yeah, good question. The power is all duplicated, so I can choose to solder it in an easier spot, but the data, I have a little less choice. But after scraping these, there's plenty of area. A little flux to make it smoother, make everything flow nicer. Yeah. With the pad tinned and the wire tinned and a little bit of flux, everything goes together really nicely. Cool. That cat is so good. Alright. Then I'm just going to copy the color scheme from my first one onto the second one here. So red and blue for power. We have minus on top. I'm really glad the plus and minus are labeled at least, even if hardly anything else is. We at least have plus minus in and out. Let's maybe strip these other ends too. And I guess we should tin those. If I don't tin them now, they're just going to get worse. I'm glad I have the fan on. I hope the noise isn't too bad for folks. There's like trains and air compressors and automobiles and stuff, but... I mean, I'm warm, but clearly Tuco's liking the rack, which is typically well above ambient. He is kind of a tropical cat. Silicone wire does not stay where you put it. Just dump that drossy little nugget. Alright, +5. And yeah, data is next to ground, clock is next to power. Weird. And green is next to blue. At least we've got the cool colors and the warm colors together. That's kind of handy. Got 3 of each here. Most of electronics is triple checking all the wires. I mean, I guess I could have a channel with more explosions in it, but that could get expensive if I actually want to build something. Oh, sorry about the hair cam. And on the output side, I've got these doubled colors. Oh, another question from Carlos in chat, who says, do you wipe off the flux residue with alcohol or something like that? I had an issue soldering connectors to some NeoPixels. They were unreliable until I cleared off the residue with 99% alcohol. I don't know. That can depend on what kind of flux you use. If it's no clean flux, then it shouldn't really have an electrical effect on most circuits, but that certainly isn't no electrical effect. So if it was already something that was just like kind of on the edge of working versus not working, then bad flux, flux that causes a lot of kind of electrical interference or like leakage current, that can cause problems. It could also be a bunch of other things though. But if you had your situation improve after cleaning the board, then that's kind of reasonable. I mean, it might depend on the kind of flux you're using. Maybe take a look at the solder, or and see what kind of flux is in it, or what kind of flux if you use it separately, and see if it's no clean, because that could affect it. And if it is not no clean flux, then if you don't clean it off, then it can definitely cause like corrosion and electrical problems. And then the other question is, what else do you do on your channel? That's a good question. I do a lot of different things. Right now I've been kind of binging on this robot project, but in general I like, building things and taking them apart. So I've been doing some, some little reverse engineering projects. Had a kind of a big project to do reverse engineering on. Well, I've had a couple of kind of small ones where I've taken firmware off of a particular device. I was trying to do something like that for a PLC for a company I was working for a while, and that turned into a very big project, but I was doing most of that on YouTube also. Yeah, pretty wide, but mostly electronics and reverse engineering and building things. The forward and reverse engineering, as I like to say. The YouTube channel is kind of an extension of an engineering blog that I've had for a long time. I've been running it at scanlime.org, and would often just hack on something, try to create something that I thought was interesting, and then just write about it. And I mean, I've had jobs where the primary goal is just, you just make something and it doesn't really matter how it happens. But I think I like jobs where showing the process is important. So this thing where I've been just kind of working on videos for myself and for other people, but it's always the most fun when I'm just working for myself. Because it's nice when you're doing a video, because then the process kind of is the end result. I tend to like just putting a lot of time into the details, and having a forum where that actually matters is always appreciated. Okay, so I think I'm gonna just try daisy chaining these two and see if they light up, and then swap them and see if it still works, and that'll tell me they're both working. Okay, so I've got a little breadboard over here that I can plug the inputs into. Some of these wires, when I tinned them, ended up with little solder boogers that caused them not to fit in the breadboards. Just saw Steven's comment about Tuco falling off the rack. He's got a little more room there, but I love the way his tail is just falling off. That's great. Okay, there's our animation. And I'm going to use the same breadboard to daisy chain them, just for convenience. Oh, this one is not tinned. I forgot to tin both of these. Let's turn this off and tin that. It does actually work better if I wait for it to beep. Oh, I could be using the new soldering iron. I don't have quite the right plug for it. I mean, I probably have one, I just didn't feel like rummaging for one right at the moment. So that'll show up on a future video, future stream. Okay, yellow out, green out. These wires are so small. Really stripped the minimum amount of stripping. Okay. And then let's attach these. Try not to short out on anything. Ground, future location of 5 volts here. Future home of a delightful regulated power supply. These wires, many of them I stripped a little thin, yeah, I didn't strip enough insulation off, so it's a little tenuous fitting them into the breadboard, so this might fail for that reason, but let's try it out. Jarrett says that I messed it up by soldering with the power off. That looks like a good sign. You can see the blip continue off of that and onto there. Cool. Well, that looks right. So we could go ahead and daisy chain something onto here or swap the two. I think I'm feeling like just kind of packaging up this one, because we know this one works. Oops, I'm spraying heat shrink all over the place. But yeah, I'm gonna warm up the black hot glue gun since I think we're gonna need that soon. But yeah, let's try building a ring with this. this to leak glue all over my soldering mat. Okay. So let's power this off. And let's just take this thing. All right. And let's see how that might fit. Oh, the Blackhawk glue gun, yes. You know, I generally kind of plan for the wires to be aiming slightly the other direction. So I aimed the solder joints inward like that, since that seemed like the stronger thing to do at the time. But I think to make room here to get the wire out, I'm going to aim it like, or to curl it like that. And then on the other side, I think it'll just point straight out where it needs to go. Oh, there's one step missing. So the very ends of the strip, I don't want them shorting out against each other. So a little bit of Kapton tape. That was just barely off camera, but I was like, let me recreate that for you. I was like, let me cut some Kapton tape. I didn't need that finger. Just folding a little Kapton tape around there so that it doesn't cover the LED, but it does cover the end of the strip. This is close. popsicle stick is not tweezers. Putting this around is the first step. This helps hold the LED strip in there. I do actually want to be building this on top of this base, at least temporarily, because it'll help align things. I'm still just trying to get a sense for where I have to put all the wires as I put this actually together. And yeah, the silicone wire does not hold any kind of shape. It just kind of wants to go anywhere. Okay, the output wires are in some semblance of a channel. I'm just using, sorry, I need a better camera angle probably, so that you can maybe hopefully see some of this. Getting all the wires to go in that little channel is pretty annoying. Maybe that's easier done without these assembled. This is the right orientation. Almost going together here. I'm just trying to figure out what it's actually sticking on. Might just be the wires. Let's try taking this partially apart and looking at the wires maybe. Well, the wires aren't pretty, but that doesn't seem to be the problem. So I think the way to do this with the hot glue is to get this all to fit together, not to glue the wires until it's all fit together, and then focus, and then just squirt some hot glue down in there around the wires. Maybe some on the opposite side too. Oh, this is really close. I think it's just the edge of the LED strip kind of hitting the edge of the channel instead of going into it someplace. I'm just trying to figure out exactly where that is. I like James's analysis. Silicone wire refuses to hold a position. Non-silicone wire holds the wrong position. You can't win. Yeah. Ow, I kind of want like a clamp to hold this part while I'm trying to get the other part to close. I was trying to avoid using anything too pokey before, but with this off, I think a screwdriver will be fine. There's the screwdriver. So slippery. Yeah, I do have clamps. I could put a clamp on the other side. They're just on the other side of the room, and I had more pressing concerns. I should change the way these are soldered. I think that's part of the problem. The inputs are fine, but the outputs definitely need change. I just need to put them on in the other direction. Whew, it is warm in here. I know I've said that. You're probably all tired of that. Yeah, that whole side, let's change it. Also, because this is the side that I don't want shorting out against anything, I could probably just trim off the conductive parts. So this being the output of the strip, I'm not using the power or ground, so I can just take those off by trimming the little corners. Which is kind of tricky to do under the microscope. So, I mean, I could cut that corner off, as long as I don't interfere with that grounding pad on the chip, which should be fine. So something like that might help. Okay. Okay, and then the main thing is I wanted to reverse these so they're coming out the other side. So I still need to respect the fact that there's not really any room between the strips, but the wire kind of needs to at least go this direction, and then it can take a bend pretty much right away. Okay, I know that was mostly out of focus, but it seems like it'll do. I know that kind of invalidates the test we just did, but I think I'm still confident enough in this that I'm going to assemble it and then test it. I can at least tape the thing together before pumping it through full of hot glue. Test it with it on that way. I guess I should decide whether these are going clockwise or counterclockwise. I guess they should probably go clockwise, just because that's a good default. That means I'm putting it in this direction. I mean, if I have to switch that in software, it's really not a big deal, but it'd be nice to be convenient, or consistent. Let's not touch the glue gun. That's looking a little nicer. I'm going to give all of you a close-up in just a sec. Okay, so now I've just got this mass of wires coming out of the side of my ring. Ah. Feels like that's fitting more than it was before. Oh. Trying to manually focus it, but my efforts are wasted on the servo AF. So, can we zoom in anymore? Maybe this is a microscope thing. I think this would be clearer in the microscope. So here's the beginning and the end of the strip. And there it is, actually fitting all the way into the channel. So you can see the output on the left, that has clock and data wires running out. And then the input, clock and data, and the power kind of run a little more directly out of that channel. Doesn't look like much, but let me try to get this together. Stretch. It has been a tough season for the plucky little diesel. Poor little train. Everyone just wants to fly. I mean, not that wanting to fly, I guess, is another can of worms, but... Yeah. Tape. So one side is totally fine, the other side is only mostly fine. Yeah, so that side holds together. This feels like it's not quite in. I think I might have just not left quite enough room for the wiring. Things look alright. Just need more pressing. Pressing kind of fixes it, but not quite. Just need a real section view tool where I can just slice this and see where it's hanging up. Oh, is that it? Am I squishing a silicone wire right there? I can force it closed, but it doesn't quite want to sit closed on its own. Feels like there's just something a little bit big in that area. Oh, that felt like an improvement. All of those snaps, I think, were good snaps. Oh, It is like a hot, sweaty day here, and so all this tape is going to be not especially sticky. Ugh. I'm just going to try to tape this shut so we can test it. This is... I think the silicone wires just keep getting back into a bad position. I've got to keep getting them out of there and then taping it shut. Yeah, get a little snap as I get them out of a bad spot. Let's try to actually clamp this somewhat. I mean, yeah, actual clamps might be the thing to use when I'm gluing it. But right now, tape is handy. And then the wires can kind of come out sideways like this. More arranging. I mean, all of those wires don't have to come out the same side, but they can. There's nothing keeping them from doing that. I wasn't really sure how I would delegate which wires go on which side, so I left the option. Okay, my little pancake's assembled. Let's see how it looks. So we've got the output wires. Yeah, we got power. And input wires. Oh man, just so bouncy, the wires just want to go everywhere. Alright, can we has power? Milliamps. 40 milliamps. Are we lacking some input here? We have green. We have yellow. We have 40 milliamps. Am I not running the program right now? It should be running. Milliamps. Is this a wires being too short problem? Just trying swapping the data lines in case that was the problem. Right, I guess let's scope it. Wow, we have hello from Russia and from Montreal. Hello, everyone. Oh, and it looks like we had a question about what microcontroller it was on the YouTube chat, but James already chimed in with it being a Tiva C from TI. Yeah, I think I've got the box around here somewhere. It's one of these. Tiva C connected launchpad. That's the actual model number, EK TM4C 1294XL. For this little red dude. Alright, why is this not working? Okay, there's data. There's clock. So that looks fine so far. On the output. Oh, that's clock coming through the LED strip. And that's data at the end of the LED strip, which is not surprising. Huh. Is it possible it's just sending all black pixels, or we just otherwise are not seeing any current consumption? Let's take a closer look at that clock. This is the clock after it's gone through the entire LED strip. Ooh. It's not pretty, but it should be all right. The data seems to be mostly ones. That's the data going in. Oh no, that's the clock going in. And that's the data going in. Card full. Well, at least Tuco looks peaceful. When all my hardware is just not working, Tuco's still in a good mood. Okay. Sigh. Well, I guess I've got to untape this and see what's going on inside. The LEDs are drawing the right current. The clock's getting through. It's acting like maybe a bad connection on the data line coming in. But I don't know. I feel the frustration building. Let's keep these outputs taped somewhere where they aren't gonna short out. Oh, yeah. That wire came off the inputs. Looks like exactly what I was just saying. This data wire is just not connected. That looks like a direct result of trying to force this thing together. Microscope time? Oh. This is one that I didn't really get through the Kapton layer as much as I thought. See that? I think I was scraping and I was worried about damaging the copper, but it was that yellow Kapton layer that I was just mistaking for copper. I was like, oh no, the copper is so thin, but actually it was just the tape. So let's do a little more digging. Yeah. Yep, learning experience. Learning how to properly solder this particular board. What a weird double solder mask layer thing. Oh. That just peels. See that? I wonder what this would look like if you just peeled off the Kapton in a layer. Would you just get a pretty regular looking board with black solder mask? And then you'd have maybe another layer of epoxy dip over that. Cool. Well, I'm glad I found this. This was a significantly weaker joint than it was supposed to be. And this could have failed later, and it would have been much more annoying to fix if it had. Okay, let's see if we can put that back together. I think I might try to get one of these rings together and then call it a stream, since I could use a break from this. I'm curious what people think about the really long streams. I mean, I don't know if it's really intentional. I think a lot of the time I just planned a bunch of material and then it just happens that it ends up being this long, but I'd be curious what people think an ideal length is. Or, I mean, I know a lot of people just like work while listening to this, and because I mean, that's totally what I would do too. And so the length is probably less important if you're just kind of using it as a background thing. I certainly pay a lot of attention to the length when I make edited stuff, although it often tends to be long anyway. All right. So, similar thing. These are going to come together. The wires from the output side will go behind the input side, and then they'll both come out through this slot in the ring. If there were a way to just like press a wire into this channel and have it really stay, that might be nice. Which could just be a matter of, I mean, when I designed this, I wasn't even really sure what wire I was using, so I wouldn't have been able to do that. But if I really planned ahead for that and designed a little wire catch that fits the right size wire, then that would be nice. Trying to be careful about how I lay out this wire. So I've got the output wires going left here, trying to take up the least amount of space there. And then the input wires are a little tight still. I think that might have been it. That seemed about right. Okay, then this goes back on here. Now, that seems like it might be together. Doesn't feel like it's jamming anywhere, which is a nice change. It just feels like it's sitting on this squishy layer, which is what I'm looking for. Alright, taped one side. Yeah, this part definitely wants some glue, if it works. And then taking it apart, if I need to take one of these apart to service it, will just involve getting one of these little pancakes off and then breaking the glue with isopropanol. Alright, let's get this hooked up again. I've got a much better feeling about this. I was not really understanding how it was hanging last time, but while I reassembled this, I think I got all the wires in just the right place, so I think it's going to be happier now. Alright, ground. +5. And clock and data. It is drawing 0.3 amps. That looks nicer. Yeah. I keep touching that hot glue gun tip. It's not fun. I'm pretty happy with that. So I'll want to clamp it and then glue it with that black hot glue, and I think that'll help eliminate some light leaks and keep it together. It should have a pretty wide viewing angle since all that diffusion's happening inside. Cool. And since I've got the scope handy, let's check the outputs just to make sure they're good. So here's clock. That's about what we were seeing before. Not pretty, but it should be functional. And then before, data was just all ones. I don't know, I mean, we're not going to see much because this is after the frame has been mostly consumed, but there is data for more LEDs after this, so yeah, that's what we're seeing. I've got a really bad ground here, apparently. That's only slightly better. Pretty. You can see the little binary blips moving side to side. Yeah, that's pretty nice. All right. So clamps and glue. Got a lot of these little ones. This is a little tenuous. This is definitely compressing the flexible part a little bit. Yeah. So there's what we got so far. So along here, oh, how much of that can I get on camera? So there's this little gap. You can see a little bit of light through there. The light leak isn't going to be a problem because that's not really pointing anywhere where you'll be able to see it, but that might be a good place to glue the halves together. Also, just getting the wires into the right channel and putting some glue in here is kind of my plan. Let's move this tape. And maybe get a few more clamps. Can't really have enough of these. Oh. It might be hard to remember which side of this is the beginning and which one's the end. I guess I am keeping the wiring consistent though, so the inside wiring comes out on the beginning side and the outside, or the output wiring is on the end. Alright, just trying to keep this area open, but glue the wire, or tape the wires down where I want them to end up. Okay, almost ready to start gluing this. I'm just gonna put some more clamps on. And does this still look alright? I think it does. So I'm gonna start with the area right around the wires because that's the trickiest. That's oozing a lot. Just wanted to take off any big globs while I still easily could. Just a little more around the seam here, and then I'll take off some more tape and do more of that. And I'm avoiding all the areas that are going to be in contact with the support this sits on top of. Also, it does occur to me that using hot glue to hold together LEDs that get warm is not necessarily always the best option, but I found it helps with the wiring pretty well, you know, even if, you know, don't use that to hold the LEDs onto something, but using it to reinforce the wiring seems like it works fine. I'm actually going to unplug this because I think it'll be easier to finish up without the wires connected. As much as I like having continuous integration, A lot of good surface area for hot glue to hold these two halves together. Okay, I think I can take off these two pieces of tape now and then put some glue under them. That was still warm, the one that I just put my knuckle into. Actually, it's pretty convenient that I think the places that, well, no, I was about to lie. I thought the places that I needed to keep clear were just around the wiring, but there's also some places around here that I'm probably going to need to clear off with a knife. This mostly just needs to cool. Oh yeah, that actually cleans up pretty nicely. Maybe that's just because it's still warm, but this is the area I was talking about that needed to be flat. Not much of this needs to be flat, but that part does, and another on the other side. Okay. Mostly ready to set this aside to cool. Oh, the zip tie is double as binary depth markers, yeah. Yeah, I mean, you can encode stuff in so many different ways. I mean, the encoding was kind of a second tier thing, though, because it's like, it'd be nice to have a unique color. The encoding is more like, because I can't do that. But I suppose other people might just get excited about the encoding aspect, and that seems pretty cool, too. Oh, let's make sure this fits on the support. So I've still got the clamps on, but let's see if it fits on here. Oh, nice. That's great. That's pretty much what I was envisioning this would be like. So, that seems pretty solid. Hopefully it's flat enough. I guess if I really needed to make it more flat, if it doesn't dry perfectly flat, I could sand it, but it's probably fine. So, well, I could make another one of these. I think this might be a good time to wrap up the stream, though, because I've been streaming for almost 6.5 hours. So, I think that's what I'm going to do. I think I'm gonna wrap this up, but let me know if you have any last-minute questions as I tidy stuff up and maybe see if Tuco wants to play. Unplug this hot glue gun for now. But yeah, I'll make a few more of these, and I guess we didn't get to really doing much with this piece on this stream, but I might do this on another stream unless I just absolutely get the urge to do this in between streams. So that'll be a fun thing we can continue working on. So yeah, and then taking another step back, so there's assembling the flyer. As you might have guessed, we have pretty much all the parts to do that. I haven't designed like an outer covering for the flyer yet, which I'm hoping to incorporate the awesome Tuco Flyer logo that Misty designed. So that's still TBD, but all the internal parts and pretty much all the firmware, all that stuff's done. So we're just putting it together. So that's been nice. So aside from that, I still have a decent amount of work to do on the winch bot. My next step there is I want to design and print a little test piece which tries out a new idea for how the motor and the winch attach. That'll just try out some changes to the geometry I've been planning, which make the whole thing smaller and stronger, I hope. And most of all, it'll be testing out using flexible filament to print gears to try to see if I can get them to be as quiet as a belt would be. Basically, I want to try using flexible filament to make at least part of the pinion that fits onto the motor, and then there would be a mating herringbone gear that gets made into the perimeter of the winch, or of the spool. So I'll try something like that. Well, there it is. Oh no, James apparently was off to watch some, I guess some copper pouring, and then it got to 950 degrees and then popped the breaker repeatedly. Oh. Well, I think this is cool enough we can remove the clamps. Let's at least see how this turned out. Still a little bit of warmth in here. But this is mostly cool. Ah, there's a little light puck thing. The ring is actually free to move, which is a little bit weird. I might try gluing that down if I can glue NinjaFlex with something, but it doesn't really matter because people aren't going to be like spinning this. And it just barely moves. But yeah. You can feel it's a little tighter on the side with the wiring. And then we got some nice squishy light blocking glue in there. Let's have one more power up now that we've got all the clamps and tape off so we can at least see this thing 360 degrees. I think that's worth doing. Oh, these silicone wires are really nice. Oh, there we go. Let's turn off the lights. And could even put that on the bottom piece. Yeah, this seems pretty expressive. And it'll be interesting having 3 of these that can all act independently. And it seems like I have enough diffusion to mostly hide the individual LEDs, but it's still pretty bright. I'm pretty happy with that. Alright, well, I think I'm going to wrap up the stream and go fuss with Rust some more. Learn the dark arts of futures and zero-cost asynchrony. Be back soon with some more of this. Happy Saturday, everyone. If it's Saturday. I guess it may be Sunday or pretty much any other day of the week where you are. We've got this amazing cat too. Just, you know. I was probably going to end up putting LEDs on all the robots. I ended up including that in the part of the firmware that's compiled into both the winch and the flyer. I don't really need LEDs in the winches, but I thought it might be nice to include just like a little patch of them so that you could display status or possibly force feedback or possibly just motion information. So just like maybe a little strip of 8 LEDs that can show a little bit of motion and color. Circadian rhythms are weird. Yeah, my sleep cycle's been a little weird too. I had kind of a relatively normal one where I would go to bed like, I don't know, I had like a going to bed midnight, waking up like 8 a.m. kind of cycle for a while. Lately it's been fluctuating a bit more. Had some late nights and sleeping in, and then also had some nights when I go to bed late and then just randomly get up at 6 a.m. anyway. It's weird. One more shot of this before I go. Yeah, I'm happy with how this turned out. It'll be nice actually having this robot built. And it's animated in Rust now, for whatever that's worth. It's a really straightforward Rust program, but it'll be nice actually having a nicer animation framework, which is what I was trying to get done like yesterday. Should wrap this up, or I'll be trying to wrap it up all day. Happy hacking, everyone. I'll see you next time. And thanks to everyone who supports the stream with ideas, with Patreon monthly donations, with sending in hardware. It's all been super helpful and keeps the stream going, keeps the videos coming out, keeps the research happening. So thanks again, and yeah, as always, happy hacking, and let me know if you have ideas or suggestions, things you want to see, things you don't like. Twitter and the YouTube comments are both pretty great places for that. See you later.